Hi, I'm Chris from Airwindows, and as usual, we are doing another stream. So I'm going to fuss with my windows a little bit here. I always like to pop out chat so that it's up over in the corner where it belongs. Also hides my face on the interface so I'm not distracted by looking at that, although that's not always a bad thing. I've talked before about how when you're doing like live streaming and stuff, where you look is important. So the trick that I use for making videos is I have a camera kind of like this or this. And the camera is, while I'm making a video and looking at the camera, I also have a screen which is showing what's on the camera. And I've set it up so that on the screen, when I have it set up just right, my eyes are peeking over the top edge of the camera that I'm using on the screen, making it look like somebody's there, making me look in that direction. Because if I put the screen elsewhere, I would constantly be staring off like this and be captivated by looking at the moving face on the screen, which is like over there. And that works too, that's fine, but it's all part of the YouTuber video producer side of my job. And another side of my job is going very well today, because this is the first day after the release of Consolidated. Hey, Jonathan. And yeah. So that's all kinds of awesome. And what we're following up on, and what I'm going to be doing today, although I would be within my rights to just be like, hey, Minecraft, we're just celebrating. What I'm going to do is tinker with some things I was interested in dealing with. And one thing that came to my attention, because somebody was asking me for a plugin that I had already made twice, which is something that will happen. You know, you will get that. In this case, I was getting asked for, please try to make the Hughes SRS. Well, years ago, Chad Clark from Beauty Pill asked me to do that, and that's one of my favorite musicians. And so I was very excited and flattered, and I did my level best. And the first time I did it, it didn't really do all the things. Like, he wasn't able to do the specific stuff that he was getting with the hardware device, but the hardware device was kind of bulky. So I did SRS2, and that got closer. And so now what I am wondering about Seriously, too. Here's what I'm thinking I can start off the day with. And you're not going to get that this coming week, because this coming week I am committed to doing discontinuity. It was going to be this last week, but I think it was well worthwhile to focus on Consolidated for that. But what I can do is put this in the queue, and we'll get it out at some point. Because if you remember, I've recently done biquad nonlin, and that takes a biquad filter and roughly makes it act like an analog device rather than just a digital filter. And it dirties up things a little bit. It makes it a little bit more interesting. Oh, this is a stereo plugin, so I'm definitely going to have to select this option. And we're going to do Seriously 3. And if I'm not mistaken, that'll be fun for people to have, because it'll be Seriously 2, but with one additional control, the Nonlin control, which I will let you boost beyond what is reasonable, in case that helps. And because all the filters built into Cersley are very steep high Q resonances, that's exactly the use case where nonlinearity is most, I'm going to say, advantageous. Understand that it's still technically distortion on the top of what normally you would get if it was perfect. So it's technically making it worse. But what I found was listening to what that sounds like. And distance 3 is in the queue. It is built. I have all the versions. It's ready to go. If it is, I remember people were clamoring for that, so I could follow up discontinuity with it. Yeah, being able to enhance this somewhat would be good. And that would be my way of doing it. So what I'm going to do is step through some of these things. Hopefully it'll work out okay. As always, let's see now. L and then M. So Cirrus N is what would be the next one. That's the way I'm doing these. If there is a Cersley 4, it would be SRS O. And doing it this way, I've been pretty good about, I think, entirely and utterly avoiding clashes between IDs. Like, I don't have that happening, and that's because I stick to this. And yeah, this looks like, I think I'm just going to keep this and figure out how to adapt it as is, rather than try to make it work using modern enums for it. Because normally I do enums for this, and this is an older plugin, old enough that it's got an old version of the biquad algorithm. So I'm going to be updating that so that it has the same behavior as biquad nonlin, but it's not going to look exactly the same, because I'm not interested in recoding literally all of those things just to make this. And we'll go from here and extend it as such. First order of business is to duplicate seriously 2. So we're going to literally be cloning everything over and then extending it outwards. I also have other questions I'm thinking about today. For instance, I have a little cheat sheet for my tiny control surface with which I might be able to start trying to work with console X and make sure that it is good for when it finally comes out. I'm not willing to put console X out until I have spent some time trying to get sounds with it, because there could be things that I still need to fix. I can put out the pieces of it, and I will, but I have to actually try to mix some stuff using it. And then I've also got a question on something else that has not come out yet. How can console 9 include nonlinearity without buffers? How does sine/arcsine relate to Air nonlin? And that is something that should apply to console 9, because console 9 bears a close relationship to console X. In fact, I'm using console 9 as the guts of how console X does the summing bus. And I also intend to make it so if you're running delays and reverbs and things, do it like sort of Chris Lord-Alge SSL style, meaning I will also supply console 9, and you're to put a console 9 bus on the top of anything that's receiving an aux send. That'll decode the output of the channel, which will have all the processing on it. And then you run your reverb or whatever, and then you get literally all the processing on basically just another SSL style or beyond SSL style channel. Because it became very obvious to me watching CLA working with this SSL device that he is actively using all of that stuff coming in. Like, it was never just only a reverb return as the reverb sounded. In order to work at the top level, all of your effect returns and things are also going into channels that are like all the other channels. And he's using all of that stuff, and you can use all that stuff. You can gate reverbs with the channel processing. You can apply Stonefire. All of that kind of stuff will have direct relevance to returns. The returns for reverbs and delays and things don't have, in fact, you could use a simple digital delay and kind of, tape eyes it or whatever using your channel strip. So that's clearly the next right thing. That also means any control surface that you get used to will be able to adapt to that purpose as well. And it means that my intention with the K reverbs, where there's supposed to be very little in the way of controls on them, is ideally suited to that workflow. And it means that if we have a discontinuity control within the reverb, you can also sort of dual gang that to the control surface so that the output of your the channel that you're working with, you can also have the discontinuity control built into the channel also apply to the same discontinuity control that lives inside the reverb, and then both of those things move together with one control. And all of this is basically how you get a recording system to be actually good. All of this is how that stuff is done. So that's going to be the intention. But for now, we're going to see whether we can't get a new version of this going on. And I'm going to tidy those up a little bit. And we're starting off by simply cloning what I already had, because I often like to build new things based on what already works. That is really why the consolidated is going to work so well, because the way consolidated works is once it's up and running, I should be able to add new plugins to it on a week-by-week basis starting this coming week, and it'll just incorporate the new thing and populate it to all of these platforms that I'm now able to target. But without actual bug fix, like Paul does not have to do anything to the system when it's working. The reason Paul is working away like mad this week is not because there is his end of it and he has to go and build all the plugins like I build my plugins when they are the standalone ones. The reason that he's having to do that is because he's getting everything perfect with bug fixing and last minute feature requests. Excuse me, hopefully that got off mic enough. So he is probably even at this very moment also coding on stuff, but where I'm coding on a plugin that will automatically be brought into the system, he is coding on stuff like the way that a bunch of different platforms have not updated new plugin algorithms that you select until music starts playing, until you hit play. And he's been working on that, which I sympathize because I was working on the same thing with regard to updating colors and plugin titles on the MyJuice plugin format. That stuff that I was doing. I went through a whole thing where I could sometimes get it to take on the track color and sometimes not. And I just kept having to add new places where it was checking for the information and figuring out what to do. And that's going to be what he's doing, but in the much larger and more complicated software that Consolidated is. Because there's 400 of these, or just about, but all of these are a lot simpler than what he's got. But once he has it built, he gets to walk away and his machine does the work and he doesn't have to. Meaning he can go back to working on Surge XT and Short Circuit XT, which I'm very excited to be working with. All of that kind of stuff, like Surge's stuff also lives inside Rack. I am absolutely intending to use Surge oscillators and stuff and many Surge features in VCV Rack when I eventually am able to start working on that. When I am eventually able to start doing live streams, maybe I'm tempted to promise to stream more often, and yet at the same time I know that that's not necessarily wise. For now, what we're going to do is this thing, and then I guess what I will do is tell people that the following week is going to be streaming of actual mixing and music making using whatever tool I did the previous week, and see how that goes for people. Like, see if people do want to show up more to a stream that is using these tools rather than what I've been doing, which is very often the stream of coding these tools. And that's what we're doing right now. So let's see. Firstly, I want to hit copy, and then I want to replace all of this stuff, of which there is not all that much of it, to this. I also notice that we are running Paris Console on this entire plugin, which is neat, but there's also the possibility of I could perhaps not do that. These are choices I can make or not make. I mean, it's only applying it to the wet sample, so there's that. Let's see what kind of... Ooh, and the input sample is a very simple version. The input sample, this version of Cersley, if you overdrive it, it will wavefold, which is very interesting. Some of these things I'm not sure if I would keep. I could, but that doesn't mean I have to. There's questions. There's going to be questions. Hey, Sumitha and Siva. Indeed, congratulations to all of us. I agree with that completely. Damn straight. Damn straight. Thanks and congratulations to everybody, because without all of you, I wouldn't still be here, and then you wouldn't have this. So let's see. First thing to do is build it, which it won't build the first time around. That is an artifact of how this old build system works, that the first time I build any of these audio units, it hasn't built its libraries yet. Hey, Corgito. Getting into making plugins, there is... I can give you some like real talk advice around that. What do you want from getting into making plugins? Like, what I wanted was, I thought that computer audio sounded terrible and digital audio sounded terrible, and all I wanted was to fix that. I wanted to be able to have the sounds like some of my classic albums, but be able to control that, like have that myself. That's what I wanted. So when you say, and I am looking for an answer from you here, I'm asking you this directly, Corgito, when you say getting into making plugins, what actually do you want from the result of that? There are many things, like you could want to earn money, you could want to make things sound a certain way, you could want to have a glorious laboratory of things like, this is my modular synth. On a weekly basis, it's all lit up, and when I'm able to do the work, I'm making music on that. Some people just want to watch the lights blink. Tell me what you want as far as making plugins, and I'll tell you everything that I know about it, because I enjoy doing that. I enjoy sharing the information. Hey, Dash Glitch. Well, I'm very pleased to see that this is making stuff possible for you. And I see that there's, I guess I'll decide which things I do today also on the basis of if there are lots of people and you want me to answer questions about Consolidated, I will happily do so. What I'm doing right now is somebody in the YouTube comments said, why haven't you made a Hughes SRS? And of course I've made two. So I'm making a third because I think I can make it even better. But the first order of business is to check and see whether it works at all. And for some of these things, I probably don't need to pipe this through the speakers. I can leave my speakers for the main system. Okay. So here's the answer from Corgito is, I work closely with AI and I'm interested in generative sound making, nothing for profit, just for fun. So you might get into just looking into all sorts of things. In particular, I love generative sound making. For years, I did modular synthesizer jams using modular stuff based at first in this cabinet here. I ended up getting a portable one, which is this cabinet up here. But for years, I was just adding bits bit by bit, and pretty much all of my modular synthesizer stuff for years on end. And there was never many people watching, but it was all based on generative sound making the modular synthesizer do generative patches and then improvising with it, because I've always enjoyed that sort of free jazz kind of stuff, or free fusion, free jazz rock type of stuff, and just jam sessions and such. And as I grew up, I stopped being in touch with musicians that wanted to do that, and so it rarely happened. There's been a couple of times, like at a furry convention, I ran into a fellow going by the name Husky in Denial, who is a very good musician. And this kid had, and this is like 20 years ago or whatever, this kid had an acoustic guitar, and I had an electric and a little itty-bitty amp. And we started to jam. And he started out by apologizing that he was going to be difficult to jam with and play things wrong, and please bear with him. He also has autism like me. And I was like, no, trust me, don't worry about it, play whatever. And he set off playing a bunch of chords, and I set off playing leads over them, and we just went. Because the thing is, this guy tended to think of new chords on the fly and instinctively try to do them, and nobody had been able to keep up until me. And so we had an extraordinary time, because he'd be going to like different keys, and I'd just follow right along, because I'm like a free jam kind of person. And he'd never had anybody to play with who was able to do that. They would stop and tell him, hey, that was the wrong chord, stop playing that. So with me, generative sound making is like my replacement for being able to jam with human beings, and or I suppose huskies. for that guy. So when you talk about, your AI might or might not be useful to you, I'll tell you, and we can switch away from the, while talking about this, I can switch away from the code. I will be testing that out and developing it further as we go. What AI is in the context of generative sound making is a whole other story. Because what it will normally do is it can try to mimic the way humans put words together. But the ideas it'll come up with are typically the kinds of ideas people have already come up with and expressed in words. But you can do things like encode songs into sonograms and then use like a stable diffusion, a visual model, and then turn it back into audio. And that's one way to do generative, like AI style. That's how some of the folks do their synthesis of music. But that is, to some extent, a missed opportunity. Because the deal is, like, for instance, let me talk about the modular, like this thing here. What it's doing is when I'm doing my generative stuff, I'm largely doing it based on some modules that I built called radio musics that can be set to be called a chord organ. And all that is it is a way of telling the module to play one chord or another of one note or another, but it's doing it using a lookup table. So you could make a oscillator, right? Any of these oscillators, you give it a voltage and the note goes up, right? But this stuff that I've been doing for ages, all of this stuff with the circle of fifths and chords and such, what if you could, which you can, take a voltage and instead of the note going up, it switches to a different chord that is in the key of where you started. Or if you made another voltage go up, see, this is how I'm working with this, and you can take this and run with it, like try to follow along, because I found this to be useful within the extent that it was useful. I mean, look, the album that I have put out, and I'd like to put out another one this year if I find time, but when I put out that album, Welcome to Free Luna, which is so far the only thing I've got on Bandcamp. I have an album out on Bandcamp. That album is all generative. All of Welcome to Free Luna. I play this sometimes as interstitial music on streams because it's my music and so I can. I'll do that today. Today I'll be playing stuff from Welcome to Free Luna if I need to go and get another coffee. And all of that was made using this as a live performance, just like I used to do live streams, but in a more focused and intense way, where I would set the randomization and stuff up, and the synthesizer would be selecting some kind of random position on here, and one randomization would be doing a sequence of random selections from, like, not necessarily these. But I would typically pick something closer to, the key of B or whatever. But one randomization would be doing a sequence of chords horizontally off of here, which means stuff that's in this key. And another randomization would also be following it would be the same cycle, right? It's like a pair of random values that are looping. So it would be like 1 2 4 3 1 2 4 3, or 1 2 6 3 1 2 6 3, and that would continue 1 2 6 3 1 2 6 3, and then there would be a parallel one that would be like 2 2 2 0 2 2 2 0, and the 1 2 6 3 would be choosing one of these chords horizontally, and then the 2 2 0 would be choosing how far it offset around the circle of fifths. Because if you offset by only one note around the circle of fifths, you're only adding one accidental. It's a closely related key. Whereas if you offset by just one note and kept everything else the same, you're almost completely around the circle of fifths when you do that. You don't want to do that. It's not as musical. So here's where the generative part comes in. You might ask, where do I get that series of random values? And the answer is the chord organ stuff is able to produce either chords or single notes where you select which note it is. I mean, I can put arpeggios in, and the arpeggios will start at whatever and go to whatever, but they'll be in the key that is being fed in. It's just molted out between the initial generation, two different stuff. But those random values can be produced by a Music Thing modular Turing machine, and those are available in VCV Rack too. You can take a Turing machine and have it generate something that acts like a random value, and it mostly stays the same, and then it will occasionally evolve and do something else. And the extent to which you can have that gradually evolve and change something is the extent to which you can have a recognizable jam where you can tell what the chords are and then occasionally improvise, throw in something. So when I was doing Welcome to Free Luna, and I can play some of that over the speakers, in fact. I have got that handy. Like all of this stuff, you can kind of hear it. That's me soloing over a Turing machine generated sequence. I'm pretty sure I was doing the Turing machines for this, where I arrived at something and went, okay, that's good, I'll keep that. And then I went with it. And then that key change is being done in a different way. What this album is made out of is extended jams on a looping sequence. And then if there's a bridge or if there's a chorus, that's because there was a separate extended jam that went on for like, I don't know, however many minutes that I thought was necessary. And then I stuck it in where it needed to be. So here's our verse for this one. It's called Touch of Her Gentle Actuator. And all of my leads and stuff on this are being generated. Here. I think I can put this through. But I'm not hearing it, but you are. So all of my leads are being played live over this. Yep. I'm able to send it to stream directly, and I have done. So each section of this is one continuous jam where I did the Turing machine until it was hitting a jam that I liked. That like, okay, these are the chords I want. This is the sequence I want. And then I would go for like a few minutes on, oh, absolutely, URX can be a form of generative the whole point of Rack sometimes is to do generative stuff, which is algorithmic composition. And I don't think there's anything wrong with calling that a form of AI in a limited way. And like LLMs are AI in a limited way. It's all part of the same terrain. Figuring out like, what can you change, what can you modify? And with this one, the way it's being made into an album track, and I put this album out and nobody really questioned like, where did you get those chords? They assumed I played them. I did not. I did not compose that stuff. Everything here is initially generated by Turing machines and randomness, channeled through the chord system that I was telling you about, and chord organs, which are generated. You can't get those anymore because they don't make the kind of teensy that it uses, sadly. But I would love to see that extent. Maybe somebody needs to make a VCV Rack module that does this. But yeah, the way this is done and the larger structure is arrived at is by doing the jam and just extending it and then editing it together like you were Eddie Offord editing together prog rock. That's how the album Close to the Edge was made, is they did the individual bits and stitched them together on the master tape. So yeah, generative and algorithm and stuff, this is all very interesting, and getting really deep into specifically like LLMs, ChatGPT, Stable Diffusion, as they exist, isn't necessarily going to get you there. Because these things tend to narrow down to like what people might say. They tend to narrow down to mimicking a certain thing, and when you're talking about like, you should check out another thing. I wonder whether I can do this. Oh, nonlinear circuits is one of my favorite. I have a sloth. I would love to have way more nonlinear circuits modules. At this point, I don't think I can really afford to do that, but maybe one day I will. There was a time when I was able to get a lot of Eurorack modules, and by now it's getting to where I'm starting to sell off stuff instead. But that's fine. It's all, everything is in its place. And hey, Crappy Blonde. Yeah, well, this is my album. This is, and I think, if I'm not mistaken, nonlinear circuits is like me. I think it's largely a guy and his dog. If you've seen their YouTube stuff, then you know. I think it's basically just him. And he contracts out circuit board making. Yeah. Him and that dog. That dog is always in the videos. I want to show you something else. So what I'm going to do is bounce around with the audio a little bit while I can. I want to briefly play you something, even though it is a YouTube. If you've never heard this before, might find it interesting. So the reason I'm showing you that is because, we'll leave it in SWB for the moment. The reason I'm showing you that is because that is another approach to generative music. But that is not being made by taking an LLM or a Stable Diffusion-like thing and breaking stuff down into, any more than, my album Welcome to Free Luna is being made by using Stable Diffusion to generate sonograms. That's actually a terrible way of doing it. I can tell you, the way that's being done is that person has written a program much like, oh, I can go even beyond that, actually. Tell you what. Bet you haven't seen this. Let me see what I can do with bouncing around a little bit. I'm going to want to look at Godot 4 projects. Here's the one. I don't think I actually built this into... Yeah, let's just run it. So when you say, I want to figure out how to make virtual guitars sound that good, it's been months since we've seen this. And it would be better if I was able to hear this too, but it's fine. This is also generative. And I'm not being able to hear any of the background, but I know that you are. And this is a game that I should put out at some point. It's gone a little bit unmentioned because I've been working on audio and plugins and things. But yeah, this is in fact a game that if I put it out, you'd be able to play it. And you control these things and make them go off the top of the screen, but the background is sort of generative D&D techno kind of stuff that's using an on-ramp break. And all of the things having to do with the game are interacting with the background sound. So it's extremely generative because it is super procedural. And this is not about machine learning network. You are the learning network. The learning network is not nearly as good at that kind of stuff as you are. And so, in this case, I have designed the music that you're hearing that is so much part of the game that you kind of take it for granted. You go like, oh, okay, that's happening. And you focus on the game, but it accentuates all of your actions in response to them. And the way that it is making those drums is the same way that the guy with the it is the same way that the guy with the gent thing was doing it. Namely, we are intelligently or algorithmically choosing samples and things and manipulating stuff, and we're basically doing a giant tracker machine. So I will let this finish now. It will settle itself down. No, I'll let it stop. Soon I will let it stop. I can't hear this music. Only you can hear this music, so that said, it's probably making it sound kind of awesome. And game over. So we'll quit out of there and quit out of there. Yeah, so here's the thing. Yeah, it is meant to be doing that. What you do, if you are like the guy that's trying to make generative gent, or what I was doing with that, you can see in display overlay here, here's the guts of that game. Here's all the files that go into it. And we can see that there are sound samples in here. That's how it's done. So we're not trying to make an algorithm like read all the sound samples and then just make something up from whole cloth. Instead, we are firing off these sound samples in a generative way. And there's also additional sounds there. For instance, here's a kick. It's a bunch of different noises. The Zox riff that all that was based on is this thing, but we are filtering it inside the game, and also typically speeding it up lots. And when we speed up something that is that slow, we get a neat sort of crunchy 90s pitch shift thing. So that's how I arrive at getting a riff like that and having it stand up well to just a lot of repitching. Is I started with it as an analog sound. It's the output of a Zox box oscillator at very, very low pitch. And that's how you do that. If you want to get into generative music, don't get sidetracked into trying to make an LLM do it, or make Stable Diffusion do it, or make a... You don't want to make a quote-unquote AI that is generating the waveform data directly. What you want to do is build an elaborate machine that is smarter about doing that and that is firing off raw samples. Like the question that I was said, and I will respond to the question about consolidated presets. I'm just trying to keep up. Scan back. Well, somebody said something about I would like to make my generative music sound as good as that gent thing that I demonstrated. The gent thing is being done using samples like these. It may or may not be repitching it, but if I could do the video game and fire off all of those, that means that you could use Godot, would be my recommendation, and fire off a bunch of samples and repitch them and filter them, and then spend your efforts working out the vocabulary for what does my generative thing do. Because that's what the gent guy did, is make sort of, rather than making neurons that don't even understand what a sound is and trying to make them put out sounds, start with sounds and start recombining and chopping and mixing them. For instance, do you want to be able to mute stuff abruptly? Do you want to be able to just have everything sitting in seemingly a realistic space, in which case you don't want to bounce the mix side of things around abruptly? What you want to do is parse between different audio samples and perhaps repitch them. And Godot, I think, is a great way of doing that because it's a game engine, it's open source, it's freely available, and you can get all that stuff working, but it's also set up very efficiently because the sound is not necessarily meant to be the primary thing in an engine. And there are some limitations to it, but my hopes are, in particular, I would love to see the work on Airwindows Consolidated go into Godot. Paul would love to be able to make that stuff as a code module. And if that became a code module, that the people in Godot could be like, okay, now you have close to 400 different effects that can be brought into your Godot mixing system. Because it turned out with their ability to do buses and stuff, I was able to do some things like that, even though I had none of my own effects available. So there you go. Like, if you want to be able to do generative stuff as good as that gent, or, I mean, dare I say it, as good as Welcome to Free Luna that nobody spotted as like, wow, that's AI. Well, it's a modular synthesizer rather than quote-unquote AI, but people would tend to assume that it was human composed. Because I use this to design the way that it comes up with chords and notes and things. It comes up with chords and notes and things based on the circle of fifths. and picking chords that fit within whatever key it is. It's not just going like, okay, randomly choose a chord, now randomly choose whether it's major or minor or seventh or whatever. No. It's very restricted. So if you're playing a C major chord and you play an E chord, that E is always going to be an E minor chord unless you jump to some far removed key. Like for instance, you go this far away and you can play an E7, an E major 7. But building in that kind of understanding is what gets stuff so that it's actually pleasing to hear and experience. Oh, cortical larvae, you have actually reminded me of something, which is that I've had a new idea for reverbs that I would like to try. I would like to try a undersampling reverb, in which you'd basically be dropping the sampling rate to make it bigger. So you'd have the same basic reverb, but it would be operating using the undersampling technique that I already use for stuff, but even more so that it would become like DRes. But it would be doing a reverb sample rather than just passing through the sample. I'm not sure if you're familiar with DRes. There's been so many different plugins. Go and bring up DRes in Airwindows Consolidated and play with it. I feel like there have been other questions, so let me continue looking through chat. Igor was saying, nice to have presets to individual plugins. I don't think we can. Or maybe, that is not what you meant, but that is actually the answer. So when you say save presets to individual plugins, if you save a preset, it's going to include what plugin was selected, but yeah, we don't have subcategories for presets. And I'm feeling like that's the way it's going to stay. So what Paul meant by that is when you save a preset in the whole system, it's saving the settings and it's saving which plugin is selected. And indeed, it should just all work, but that's not what you meant. You meant be able to have sort of subcategories for presets. Well, if you're able to make the DAW do subcategories, then that is all well and good. But I don't see a way of, like, some of that stuff ends up being shunted off onto whatever the DAW is, meaning that people can make DAWs that have all kinds of complicated lists and things for organizing this stuff better, but we can't necessarily do that from inside the plugin. You can use naming conventions that would help. That is something that occurs to me. I would suggest if you are making lots of different plugins settings and making lots of different presets using Airwindows Consolidated, I would put like the plugin name first and then space and then whatever your preset is called, because then if you're just stuck with an alphabetical list or whatever, at least you can scroll through it. Hopefully you haven't made so many presets that you find them unmanageable, so it'll be somewhat limited. But then you can go immediately to like, okay, these are the compressor presets, because it starts with compressor, then like space or colon or whatever it lets you use, and then your name of your preset. And that's a good way of dealing with the single overwhelming list, is to use some naming conventions to work around that. So let me see. Let's bounce back to some other stuff. That's been an interesting and useful tangent. Crappy Blonde, I absolutely would like to do that. However, it's not going to be good for today. But I feel like no, don't worry. I don't hang around with people who are easily offended, so don't worry about that one bit. If anybody is like super mean to me, I'll like make fun of them or something. But people who are well-intentioned, this is going to be a pretty accepting environment That's also the way the surge synthesizer subcommunity works. And especially when I finally put out like Console X, you're going to see more in the way of demonstrations. Excuse me, I'm coughing a little bit. I'm having a little trouble there, but it's early yet. It's barely an hour into the stream, so I've got another 7 hours to go. That is winter still working its way out of my system, is what that is. Yep, and Igor, that's what I would say is use naming conventions to deal with that one, because the plugin's not able to do it for you. It's only able to save its own presets into the DAW. So let's see, where were we at? We were going to test out whether the Cersley 3 works before adding discontinuity to it. And then there's a variety of other things that I could do. And you're not actually hearing this directly because it's only on the laptop, but you'll hear it in a little kind of shrill, nasty way. This is not going to be a big listening to stuff off of the laptop day. So Airwindows. I basically know what Cersley sounds like, so we're going to go straight to Cersley 3 and see if it loads and works. I'm willing to believe that is center. I'm willing to believe that is width. And here's our cue. And there's our level and dry wet. Yep, what Q is doing is it's sharpening all of the resonances. And center and space work like the original Hughes SRS. I am definitely propagating more controls into here than originally existed. Ideally, if I was to do an exact model of the SRS, I would find the correct setting for all of these and just keep it. Hey, Corgito. Well, thanks. It's been ages since anybody has bought that album, but it is still like, I mean, if you love what you hear, you can have a super high-res version of it. I'm pretty sure big chunks of it are, I'm not sure if I ever put the full album up on YouTube. But I did videos for some of them, so tracks off of that are on YouTube. But then I put it out as a Bandcamp, because, like, why not? Like, if you make music, no reason not to. People can buy it or not. People did buy it at the time. I haven't been talking about it that much, although sometimes I play it. You know, I play various things. I've got a whole bunch of stuff for interstitial music on YouTube where some of that you can't even get anywhere else. Like all of the roughly 1 hour long things, you know, like Nuke and Pave and so on. Those are also modular jams, but they're not edited down the way that the tracks on Welcome to Free Luna are, so they sound more jammy. And those were all originally YouTube jams. And those could go into Bandcamp. I just haven't done anything of the sort. Anyway, I am wondering, particularly since we are playing a loud thing into it, I wonder whether I can make this actually work better by stripping out the console processing and instead trying to get the analoginess through the nonlinearity. See, because here's the thing. Might be able to get better results this way. Because we won't have applied it yet, But we are now looking at getting analog style results not through the primitive method of just distorting it or applying a console system to it. Instead, we're talking about doing all of the filters as Nonlin filters. Good morning, Sweeter Than Anything. So let's try that again. It's still going to sound like absolute garbage because this is off of the speakers of the laptop, but all the same, this should give me a picture of what changed. And I might very well be able to take this up a notch. Yeah, maybe so. This is more of the side. You can boost both center and space. That's like the SRS. It can be narrower or tighter. I think this is moving in the right direction. This is a significant change over the previous ones. Meaning, now we've got Seriously 3 building, and we've already changed it from Seriously 2. Oh, you can't hear it. You can't hear what I'm doing. There isn't even a good way to feed it to the stream. Sorry about that. I can't hear it either. This is just the laptop. I'm just going by how I know stuff interacts with this broken-ass laptop, which is what it is. The speakers don't actually work properly. The bass buzzes and rattles. Everything about it is super busted. But it's telling me what I need to know. We're going for something interesting and different. Remember, if I'm able to do a Seriously 3 here, which is no longer doing what the previous one did, the previous one is still, it can be like Galactic or whatever. If I do this and I bring it into its new zone, so it's a third variant on Cersley that does a whole other thing, which I think is better, then it can be like Galactic and then Galactic 2. I did Galactic 2. It's better at doing a specific kind of space ambient. And people generally like Galactic 1 better, and so with Consolidated lets me put Galactic 1 as recommended. And it'll be the same with this. I think I can beat the hell out of Seriously 2 using this technique from what I hear. The fact that it sounds, if you say it sounds more distinct early, that doesn't necessarily mean it's going to be better in actual use. I got to go by my instincts on this. And my instincts are leading me in a direction. And we're going to see where this takes us because I'm real interested in this. I might actually even use the big speaker audio, in which case you'll be able to compare them a little bit differently. But let's see, where's our B, biquad? Why am I going to D? So here is where my code for the nonlinearity in biquads lives. And I don't think we have anything special here. No. It's applied here. So we do have it smoothed, but this is the technique. And this is where I do the reversing of polarity, and this is where it fits into the algorithm. So we're going to port this over, and let's see, we've got an additional control, and that control is Nonlin, and it's partly smoothed. I mean, it's partly scaled. When it says POW get parameter kparam 4, 2, what that means is most of the numbers are going to end up smaller. Because power means take the result of this, which goes between 0 and 1, and multiply it by itself. If you have POW 3, it's multiply it by itself 3 times, twice. And this is how we scale the movement arc controls so that they can cover different ranges for different control positions. But in order to start working with this, I have to add a control to Cersley. The rest of it can stay the same. But we need to make it a little bit more so. And so we're going to expand it outwards a little bit. And here's how I'm going to do that. I'm going to manually type in all the new stuff until there are 6 controls instead of only 5. And in fact, I think I'm going to tack it on at the end right before the dry wet, just so that everything else sits in the same place. Not that that will really matter, but if anybody is really used to using Cersley 2, then they'll be also used to using this. So let's see how this goes. Very, very little needs to be done. It's just being done manually. It's being done by hand. And then everywhere else. So let's see, I'm just looking over and making sure that everything looks right. I can tell one thing, which is I won't want this to default to 1. We're going to default it to 0.5. Nothing needs to change here. And I'm probably willing to just go ahead once I've added the control rather than checking to make sure everything still works, because I'm pretty sure that I can do this in such a straightforward way that it's not going to confuse me or lose me. So there's our 6th control. These are all very much 0 to 1, which is exactly the same as in VST2s anyhow. And now this all needs to apply to parameter 6 instead of 5. Now we have 6 working controls, and it is time to put it in here. Let's leave all the rest of that stuff alone, including this stuff. This is all fine. I'm going to have to check as to which of these things gets replaced, but that's fine. I think it's going to be biquad 2 and biquad 4. We're also going to make all of these be doubles rather than float 64s because there's no special reason. And that doesn't really need to be there, but it's nothing really, it's fine. That's fine. Both of these things mean 64-bit floating point number. Back in the day, I would be using float 64s because that's something that turns up in the audio units. And I don't know why they asked for a different variation on that. And like I said, going to want to scale it like this one scales it, except for it's a different number. Or let's see, Q would be, yeah, param 4. Okay. And I have to do that up here because I'm using it with this stuff. From half to double intensity. What does that mean? Do I have a special number on this one? No, don't think so. Okay, so this is still a 0 to 1. I know what Q means in a biquad filter. It's a resonant number, and if it is 0.707 or something along those lines, it's Butterworth, meaning no resonance. And then we continue sharpening it. So this is taking this control and starting at 0 to 1. And now it becomes 0.25 to 1.25. And then focus M becomes a lot larger. In fact, it's being modulated by param 1 and param 2, which are the space and so on and so forth. So this is ramping up the steepness of the controls a lot too. But in a funny, weird way. I think it's broadening stuff as we go steeper. And I think param 1 and 2 also work as volume levels. See, depth. So here's our proportion to mix in the filtered stuff. So what I'm trying to figure out is, does this end up being 0.5 being centered, or is this actually working on... No, that's still going from 0 to 1. This is me just trying to figure this out. I almost am certain that as I ducked mid to 0, it cut out, it went silent. That would be explained in here somewhere. So here's some other interactions as well. Gain M is going from 0 to 2. Gain S is going from, well, a gain of 0 is silence, so this is good. So this would mean that the output of 0.5 times 2, that's unity gain. That turns the number as 0.5 to 1. And multiplying by a gain M or a gain S of 1 means no change. The question becomes, at what point do these boosting things kick in? So proportion to mix in the filtered stuff. This also becomes 1. Does it stay 1 though? And of course, we do want to modulate all these little filters. Anybody doesn't know what nonlin means, that's what it means. And here we go. So here we are doing this kind of stuff. This is a little novel. I'm not sure what I did here, but that's in use in Cersley too. So we'll hang on with it for the moment. I am going to make a little command decision here and have temp sample be declared each time rather than declared up in the buffer section. And what that means is we could declare it here and just keep reusing it, and that'll be absolutely fine. That is normal. That is what you'd want to do. Like after this point, we're able to just keep using it, and it's cool. we've got a limitation on how loud the side channel stuff can get. We have a distortion on that. That's interesting. I'm not sure if we want to distort side this way. I feel like maybe throwing lots of energy out of side will work better, because one thing this is doing, it's contributing to the body of the sound, but the work that I'm doing more recently centers on making the most of peak energy, and accentuating side in this way is accentuating peak energy. This might be actually making neutral stuff narrower, and that is not what we would want to do in Cersley 3. Also, we seem to have double boost on this. Side times gain S, and then again. Don't know about that one. That'll also mean it'll cut it faster too. So let's just quickly cut that out as well. We're just running with all of this stuff and seeing what we can do. The gain stuff has a lot to do with things. That also means that side gain could be accentuated. See, if gain S larger than 1, then gain M gets cut back, so we're further accentuating that. But we could also further hype gain S while simultaneously cutting gain M. If gain M is larger than 1, then it stays. That's fine. So what we would do here is bust this into its little angle brackets, which means I can do multiple statements in C or C++. If statement, you can do one thing immediately followed by a semicolon, but if you want to do multiple things, you got to put them in these. For anybody who doesn't know anything about C++, which is going to be some of my viewers. And then rather than gain S divides equals by itself, gain S multiplied by. So what's going to happen here is this will go from 0 to 1 to 2. And if it goes beyond 1, it is starting to cut back the mid-volume, which is part of how it does its exaggerated brightness, but also it will go gradually to what the previous code did, but with more ability to throw peak energy aggressively into the side channel without distorting it, which also means less aliasing, because this is an older plugin and it does nothing to attempt to compensate for aliasing. It depends upon a variety of things, honestly. You could run Cersley 2 with oversampling and it would be fine with that. But this one is not going to throw the same kinds of issues there. So that part should now work and do as aggressive of a side boost as, see, Cersley 1, I don't think had any of this. It only did the filters. And because it only did the filters, it was limited in its ability to get really crazy with like washy side stuff. So I feel like clipping the washy side stuff, even with the soft clip that I was doing, is not the right idea. And so we're not going to do that. And here we have, oh, well, look at that. I don't think we need to be doing all of these as integers. Not going to make a big difference, but one of the things about that is that it was starting out by declaring an integer and then trying to go from there. And there's no special benefit to doing that. Like, this is a double precision number. So therefore, if you tell it it's an integer and then divide by sample rate, which is a double precision number, all that's going to happen is it's going to be like, oh, and then also I have to convert this. So we might as well tell it, like, yeah, these are all floating point numbers. Just use that. That might or might not save a little bit in terms of efficiency, seeing as the program doesn't have to go up, first make an integer, and then convert it to something, and then do something with it. So let's see. So where were we at? We have successfully defined, down here somewhere, nonlin. And that's all we're doing here in biquad nonlin. So the next step is to use it where it needs to be used. So this is all very traditional calculations, just the same as we're doing up here, generating this stuff. This is all very traditional. And this is all the bandpass format. And since the bandpass format always generates M10 4 is negative M10 2, you can just use negative M10 2 here. And that's what we're doing with nonlin. We're declaring a thing. We're calling it dia0 for some reason, but it's all good. It's fine. And we've busted things into mid and left and right and side. And each of these get their own little boost. So what we're going to do is nonlinearize these guys and then hear what that sounds like on the terrible little laptop speakers. And I may want to fire up the big speakers. I am not able to send any of this through to the stream, sadly, but I should be able to unplug, as I often do. Unplug the fiber optic cable, plug it into the laptop, and go. But for starters, all of this is fine. But some of this won't need to be calculated anymore because we're never going to be actually using any of these that are 4, the array entry 4. Because this is the part that's being replaced by a nonlinearity. Turns out, if we frequency modulate R3 2 and then R3 4, that's what nonlin is. That's what it does. So let's grab this and plunk it where it needs to go. And we're going to need to apply this everywhere it needs to go. So first, let's get a template that we can copy off of. I'm going to make it work once. So a bunch of these comments are probably not relevant. I feel like I'm not, well, no, I guess we are using 7 and 8, aren't we? Every single one of these says 7 and 8 store L channel, and then we're using 7 and 8. But see we're doing a silly thing here, but it's harmless. We are doing L3 and R3, but we could just as easily be doing L3, 7 and 8, and then R3, 9 and 10. That would work too. So this is silly code. This is wasteful, but no harm done really. I'm just looking at this again and being like, what was I thinking? Okay, That's fine. Maybe I should do, well, here's the question though. Like, how is this going to interact with my nonlinearity? Do I want to just use a dedicated biquad filter for each one? Or can I do it in this way where it's keeping the same basic settings of all of this stuff? I feel like maybe you can do that. So I tell you what, let's start off by doing something else. See where it says 7, 8, and then 9 and 10? That means we don't actually call this biquad L and R anymore. That's going to be a little tricky. But all the same, it should work. And then we could also do the same thing. No, I'm not sure if I want to, though. So here's what I'm currently thinking about. Do I leave this the way that it is? Do I simplify this so that they are all mono biquad filters and they just claim to be left and right in the filter itself? Or do I go with making them be stereo filters and trying to apply that to the left and right channels where it doesn't actually apply very well to the mid and side? Like, these are called 3, 5, 7, 10, and so on for a reason. That has to do with which frequency band they're dealing with in some way. Something about it is that. So it's not quite as simple as breaking them down to given numbers on them. You know what? This frustrates me. What I'm going to do is, firstly, let me make sure that all of these are referring to the right numbers, and that looks good. With this, we are now counting up to a hard-coded number rather than using an enum. And with this, 9 and 10, we don't use. So what I would like to do is simplify all this down and not be messing with this, like, all of these contain stereo values, but we're always only using the left channel, unless if we're doing something that says it's the right channel. In this case, we're using the right channel and ignoring the left channel. Let's make that go back to 7 and 8. 7 and 8. I think those are the only places. Yeah. Yeah, the mid-side stuff isn't doing any of that. And that's all that was in the filter. So we've now simplified it down in this way. No samples included in here that refer to stuff that we're not even dealing with. Meaning, we can make this 2 smaller. These all worked before. So if we made the spaces 2 smaller, And then we make that 2 smaller. And then we go up here because now it would break unless I make this 2 smaller. This is why I moved to enums for this. If you do enums correctly, it fills in the variables in such a way that it's conveniently and effectively doing what you want. You can say if it's less than max number because you define the max number in the enum, and it basically does what you intend. We're not doing this. This is an older version. It was actually Bacon Paul, who did Airwindows Consolidated, who suggested I use enums, and that's when I started doing it. But this is before then, and so this is old school. We are not declaring this up here anymore. It's being declared inside the algorithm. So now we've got something. We've done enough changes. Let's make sure the sucker actually works. Should be fairly easy to find out. And the reason I'm using Discord Welcome Home for this is because it is quite loud. Cut that back, and let's give a lot of space. Yeah, we got a lot of gain on tap here. And we can cut everything back to silence. And I am curious now. Oh, but why don't... Oh, I bet I know why I'm not seeing the nonlin. We're not using the nonlin, but I don't see it, and I can tell you why. Interesting. Okay, so these filters are always present if you have the plugin on. Center and space being 0.5 are not bypass. That's important. That also has a lot to do with the sound of things. But I bet I can tell you why it wasn't showing all of the things. Use index parameters, k number of parameters, 1, 2, 3, 4, 5, 6. Here's 1, 2, 3, 4, 5, and 6. Didn't use that variable, quite correct. Let's make sure we are defining all of the things correctly. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We do this, and then key number of parameters is in fact 6. So let's see whether maybe I just didn't put it in properly or something. Like you have to put it in the components folder for it to do anything. Let's try that. When we try this, we should have nonlin showing up this time. If not, something has gone wrong. Yay! It's supposed to have started at... One of the things that's happening is it's loading previous settings. And so the previous settings had dry wet at full wet. And so it remembered that the fifth control was 1 and set it to that. But the default setting for nonlin is actually 0.5. Yay! Got that going on. Next, let's use this variable. The remaining piece is fairly simple, and then it's a matter of sort of checking the audio of it, and then maybe trying some other stuff. We've got other things to do too. But it'll be nice to throw this one in. I was being asked for the Hughes SRS thing. And I was like, I've already made 2 of them. What do you want from me? But in this case, I do believe I might be able to make this way better. And we'll see. And here's how we start. Each one of these dia 2 equals negative dia 0 because it's bandpass. Might also just do something different with that, or maybe not. I don't know. We'll see. So now that is set to be bandpass. And this is set to be 1 plus input sample times nonlin, which is the way that we are handling the pressure affecting the capacitor value. I have seen people further talking about this and suggesting that with some of your ceramic capacitors, you can lose like 80% of your value by fully loading it up to its rated voltage availability. That's a big effect. And that's all over like guitar amplifiers, things like that. Just all this kind of stuff where you're using capacitors that are subject to this effect. This is not a subtle effect. This is not like dithering grade subtlety of an effect. It's no wonder why a lot of software doesn't give you the sound. Anywhere we're using cheaply available capacitors, anywhere that you can be like, oh, let's throw some ceramic caps on, it should be fine. The pressure of voltage against them is going to have wild, huge effects on the nonlinearity of them. And so we're going to see whether we can't make this do something. So here's where we find where this plays in. This is our dia 0 and how that gets affected. It will mean that we'll get to skip some of these things. And here's where it gets applied. Checking over here to see if I see dia 0 or dia 2. Nope. So this is exactly the same pattern that we see here. They're just different names. Instead of SL1, it is 7. Instead of SL2, it's 8. And all of these are going to follow the same pattern. So we need to replace biquad M2. Ooh, and we're not going to be able to use A0 for this, are we? But I can tell you what I will be expecting to find. Firstly, the name of the one we're working on. And then this is not an enum. This doesn't exist here. But the thing that we're replacing is this thing here. So in the same content, in the same concept, what that means is we're using this one. And this is going to be the same for every single one of these. So if we can get the pattern right, we can use it for all of them and just change the identity of which biquad filter we're using. So this is going to be 2. This moves from here to here, and this gets used here. And this is what this became. And I believe since this is not being reused, we don't actually need this. We just need to make it negative. So here we go. That's used positively. And then rather than use this number, it's a little off the screen, I'm sorry. Rather than use this number, we can just use dia 0 again negatively. So that is the same as this. And that's all we have to do for every single one of these. Although, the input of these I think I might be slipping up. We're going to be having to modify this as well, because we're not doing this based on the pressure of input sample. We're doing this on the pressure of mid. Let's give that a try. See, here we have input sample everywhere, right? And so it's input sample times this, and this is the nonlinearity. But here we're doing it on mid, so we have to have the pressure of mid modulating it. And that's going to be interesting. That's going to make an interesting effect. It'll make it push on the capacitor even harder in some circumstances, and not in some others. So that's interesting. And I think we can also set that there just to kind of check, have it be a little bit more visible. Or we're probably done with that part. I think we're done with that part. So what we're going to be doing here, and what the heck, I'll put it back. Is now both of these are also already declared. We just have to change all the bits. So instead of double, I'm honestly not sure what dia 0 meant. It was dia 0 and dia 2. Well, we're doing a nonlinearity, so it's discontinuous. And we're doing a biquad filter. Where would I have gotten dia? I can name it anything. It does not matter what this variable is called. But all the same, and I can just see, we can make all of them change. So I'll worry about that later. If at all. Like, I don't have to worry about it at all. So here I need to first go through, put this in everywhere, which I will do now. I'm going to try to be methodical about this. So that I don't distract myself or get lost. Getting lost means you do wrong things and screw it up. I don't want to do that. So the first thing going on here is that since I have this, I've got two stuff in this dia place. It's not going to be M2 every time, and it's not going to be mid every time. So first order of business is to change the line that I just put in, so that it corresponds to all the places it needs to be. For instance, this is M7, but it's still mid, so mid can stay there. This is M10, so we got to do M10, but it's still mid, so mid can be there. However, now we're going to be doing S3, and it's side, not mid, so side, and then S5 instead of M2, and side instead of mid. So now this matches, and we're going to continue onwards into these here. This is totally not going to be M2, it's going to be L3. ISO sample L is this? Okay. Whatever you say. R3. We don't want mid, we're going to do ISO sample R. Here we have an L7. Try to do that as best we can. Same deal, I'm sticking to the pattern. I'm trying to make this as boring as possible so that I don't do it wrong. I stress out when I run ahead too fast with this stuff, so this is not a day where I should be stressing out. This is a day where I should be enjoying the fact that Consolidated came out and that people are enjoying it, and that I will be able to add this very plugin to it sooner than you think. But I want to make sure it works before I do that. So R7. Did I get that right? Looks like it, yeah. And ISO sample R. And that's all she wrote. So back to the top. Yeah, if we build this, it'll actually... Oh, no, it's not declared in this scope. What scope would that be? What's going on here? Oh, I see. Simple mistake. I've camel cased it. So it's not actually going to work, but it builds. The next thing we must do is go in and apply it everywhere it needs to be applied. And that's actually pretty straightforward. Everywhere it says this, it becomes 0, and everywhere it says this, it becomes -0. By which I mean DIA 0, where I have forgotten what DIA means. Go figure. We'll do the best we can. That is all I can promise. Same deal here. Gotta remember to hit the negatives every time, or terrible things will happen. Once I finish doing this, if I can get it to build, I will put it on the big speakers and you can at least hear it a little better. You'll hear something happening even though you're only hearing mono. 0 and -0, which is my way of saying I must hit minus here and make that parameter be negative, or it will fail to be bandpass. Okay, so far so good, and on to these ones. I'm going to rename this once I'm done because dia 0 means nothing to me anymore. And I gotta remember to do that negative here. That's important. That changes the whole shape of the filter. It stops it from being a bandpass filter and starts it to being a poorly designed low-pass filter if I do that. So I got to remember not to make that simple mistake. I love it when people are like, oh, look, Chris the genius. And look at how I'm struggling with these rudimentary simple things. Go figure. This is part of the cost of trying to think on different levels, such as I'm designing things like Console X. Like, I got to be able to do stuff like that and manage the levels upon which that functions, which leaves me barely able to do this stuff, which is very primitive, simple coding. But that's just the territory, right? That's just kind of how creating things is. Similarly, if some of you who wanted to do generative music get really good at focusing on the stuff that matters there, you might end up not as good at the ChatGPT LLM kind of stuff as others, but you might be doing work that's more important because you're not the best C++ programmer on the block or Python or whatever it is that you do. But you might be thinking about all of the stuff around the concept and task of generative music producing in a way that others are not, which could end up being the important part. So let's see whether we have a working plugin that doesn't blow up and die. That's important. That worked. We'll pat it down a little bit. And we'll push that filter a little bit. One thing about it, we have a boost built into this, and I can't get around it. That is okay though. Turn it in. Wonder how much we have to cut it back to have it be a comparable behavior. I think I'm onto something here. The hilarious thing is trying to listen to this on a laptop, which has like one central speaker and a couple of auxiliary ones, and they're all broken. But if I can hear the airiness happening on this, that says something. We might have got there. It might be something where I can go and make another cup of coffee and switch over to other levels of work today. We'll see. But my next stage is to take this little device and bring this over to the big speakers, because I can't run the laptop into the stream directly. At least I'm pretty sure that is the thing I cannot do. All right, bigger speakers. We're gonna have to pad. Oh, interesting. The stereo widener of the beast. There we go. Let's keep it going by having it loop. That's better. With 0, not that interesting. That's better. That's super exaggerated. Neat. Whereas if I did the same thing, let's make a quick little effect stack, shall we? And then we will make them level matched. That's loud. Same setting, same cue. Same dry wet. Level. Same everything. So previous. Let's really crank the hell out of Nonlin. Hear what it's different. So previous. That's lively. That's something. Okay, that worked. Okay, so here's Seriously 2. Here's Seriously 3. Yeah, this is like relatively dead compared to Cersley 3. This is definitely what it needed. That's the air. That's the space. Original, new. All right. So that was a good 2 hours of mourning. That absolutely worked. And the reason I thought that it might is because this is narrow little bandpass filters. And narrow little bandpass filters are very well suited to this particular kind of nonlinearity. Now, whether this is exactly what's going on in the Hughes SRS, that is not necessarily something I even know. But what I will say is that it's throwing more attitude and character than it did before by a really long shot, and I've got that on a control where you can dial it up and down. So, all in all, that is good. Got there. Hey, David Chapman. I think people have been calling that a kind of compression, and I never really understood what they were talking about because it's like compression is compression. What are you talking about? Bringing up low-level sounds is like makeup gain. Squashing down high things is compression. So I don't really understand that part. That said, there's probably a way of getting there. And you are specifying that it's MV2 specifically that makes a particular point of doing this, so that's relevant. There's a point to that. Let me go and put like Cersley here, and then we're going to start playing with some reverbs and things in the afternoon, I think. But what I'm going to do for the moment, and I can actually, this is going to be fun. I can show you something. If this works, which hopefully it's going to work. I've been working on Airwindows Meter. So people were enjoying Touch of a Gentle Actuator before. I can fire up Airwindows Meter and then go off and make myself another cup of coffee, have a bit of a breather. The doing Cersley 3, as exciting as it is, it's like, yeah, I was pushing pretty hard to do that correctly. Not that it's actually a hard thing to do, but I was hoping it was going to do that. So it's mid-morning break time, and we're going to put on some music that you can hopefully listen to while I do that. I'm not sure quite how much time it's going to take, but this is the new version of Airwindows Meter. And I'll leave you with this. I'll play you the same music that some people were enjoying before, but now you can see what the new version of Airwindows Meter does with it. And so can I. I will explain that later. So let's stop this while it's going, and I will explain what it is, and then we'll move on to something else. So this is Airwindows Meter, and the top is indeed picking up RMS loudness, but it is also showing peak energy. It is showing peak energy as these little dots. Now, as the peak energy is more optimally distributed against slew energy, the dots will become heavier and darker, and then they turn blue. And blue corresponds to unusually good sound quality in certain kinds of ways. You could call it star quality. You can see that this track of mine, as fun as it is, doesn't have lots of star quality, but it has little bits of it distributed here and there. This is the slew meter, and as stuff is brighter than it needs to be for the volume that it is, which in this case is lots of stuff, the black spikes coming through. And note that it's not all black spikes coming through, but I've got some repeating thing going on there that does not need to be as bright as it is. And then this is a zero crossing meter, which is an unusual thing that other people don't really have. And that is also supposed to be distributed. And as such, we can go and demonstrate something using this. I can set it to Rain audio. And we can play with some of my potential evergreens stuff. In particular, here's my go-to for hit record sound as exemplified pretty much ideally. This should not make a noise on stream or in the room. Yep, we're good. So this is the Beatles playing Drive My Car. And you can see the way that the peak energy is being distributed. That's pretty much exceptionally good. The fact that it is as loud as it is, it's a loud track, you can't actually tell, other than with the green and the red there, that it is one of those early Beatles where everything is on opposite speakers and it's really weird. That doesn't matter as much as where the peak energy is. You will also notice that the slew energy is also dispersed just about perfectly, and you are still getting some spikes up there, even though it's such an old record. And then the zero cross energy sits here. Now, if we were to go to something like, for instance, classic AC/DC, that's a Mutt Lange production. And we've heard little bits of some of this stuff in one of my videos, the Content Hide D video. And a Mutt Lange mix, we'll let it sort of get going a little bit. We're going to kick into the part where it's louder and more is happening. And the Mutt Lange mix has more aggressive dynamic peaks for the drums. It's punchier. And then the distribution of the peaks in the slew energy is extremely intense. You'll notice that where mine had the high frequency spikes all through it, Mutt Lange stuff barely has high frequency spikes poking out at all. It's all very smoothed off, which we can demonstrate by looking at some other Mutt Lange, like let's see, what would be good? What would be good? Here we go. Here is more Mutt Lange. Def Leppard photograph. I'm still getting over the wintertime. This is arguably an even better example of your hit record production. This also, same deal, just like with mine. Peak energy, RMS loudness, which is not as loud as you think it would be, and brightness. Although the brightness is poking through a little bit more here, you do find coming off of these old vinyl records, same as that old Beatles record, you can get a lot of spikiness out of there. And we have this tendency for having his like produced reverby kind of stuff all sitting in that range where it's reading his hit record stuff. And we can demonstrate that by looking at not Mutt Lange, but a Trevor Horn mix. Here's Yes playing Leave It. Trevor Horn has a slightly different signature than the Mutt Lange stuff, but this leads off with a cappella vocals into heavy digital reverb. And that's one of the ways that you can open up a song, not at full volume, but due to the way the voices are mixed and the way that the reverb is mixed, it is saturating that area of this is the hit record sound full on pretty much at all times, even though it's only a cappella. A cappella is actually a pretty good way of doing that. And then the body of the song over here, we've got a lot more going on. Same kind of distribution. Same kind of distribution as all of this stuff going on in the peak energy. One thing about a Trevor Horn mix is we're not sitting all the energy in a band that's as loud as it can go. Instead, there's a lot of space around it, and it makes it a little more relaxing than stuff that's pushing so hard that it's just slammed. Clicked on the wrong thing, made it go away. But you'll notice the peak energy really tells the story with the Trevor Horn mix. We've got some sounds that are actually quite aggressive, but it's still not spiking all the way up to dominate the entire meter. There's a limit to how bright the brightness spikes will go on this classic stuff. That's why it sounds the way that it does. It's really active. There's a lot of energy going around in the highs here, and you hear it and it sounds very 80s. It sounds very bright. But it is simply not going to blast in the way that some other things would. Let's briefly look at an old Kinks song, All Day and All of the Night. And with this one, this sounds really loud. And it shows up as it's extremely saturated and all the energy, the peak energy all sits up here. It'll spike higher than that, but it's acting kind of like a loudness war record in a way. It's the RMS goes really loud. This is a very dark gray compared to some of that stuff. So it's a really distorted record. This old Kink stuff is a really distorted stuff. You're not getting much variation here. This would be like the chorus or something, and it's just a full blast. It just sounds incredibly loud and distorted at all times. You could make that like 1 dB louder without obliterating it, but it's pretty close to as loud as they come. And then the brightness only goes up this much because it can't really go up any farther because the equipment wouldn't let it. It sounds very mid-rangey, and that shows in the zero cross meter. Whereas if we look at, for instance, what would be good? How about Pink Floyd's Money? There it is. And these are definitely things that I'm going to be doing evergreens of, and it's a question of whether they let you hear it. On this live stream, I don't feel like having the stream get bounced out of the world, and so what I'm going to do is put this stuff on and just show it, because this is the part that I know that I can do. I could do this to Beatles all day long and it wouldn't matter. So here is Pink Floyd's Money. And when I say that the activity of the peak energy signifies what a hit record sound is, this signifies as a pretty well-expressed hit record sound. It's also pretty good at not spiking the high frequencies up too much relative to the amount of energy that's there. It all has to kind of sit in the same balance, and that's what this is doing. And I believe this is probably the solo section. I'm not entirely sure. I think it probably was, yeah. Saxophones are very popular in 80s music, and saxophones do pretty well on this metric. And so here we have the quiet part, which is still hitting a lot of key notes here. And then you go back to the full blast. The click that I made caused, and you'll see that we are seeing some brightness spikes poking up here on Pink Floyd Money, which does not otherwise sound like that bright of an album, honestly, but the cymbal crashes are doing it some of the time. When the high frequency spikes up past this top edge, it shows up here. By contrast, I can show you that in some of my mixes, for instance, this is Rise as I mixed it on the console LA, I didn't do as good of a job with that. And so if you do a bad mix, it can be doing things like this. This is not showing as much hit record material. I've got this balanced out not nearly as well, even though I did the best that I could at the time. It's not clipping a lot. It's not that super loud. There's little hints of goodness here and there, but on the whole, all of it is too bright, and it's stopping it from registering like, say, the Beatles records did. The little spots of darkness, the little spots of blue, are the moments when the sound is really properly in balance. And what you can see here is I have just got too much loudness going on, and I have too much brightness going on. And if you go to the chorus, it's even worse. Here's my chorus. Or actually, is this the chorus? That probably is the chorus. So you can see it is too loud, and it is definitely too bright, although there is a limit to how bright it gets, and that's the console. That's console LA doing that. But you can see this is not great. I did not do this well. It's supposed to be balancing out much better so that much more of this is registering as high quality. And I can also show you something where it's basically good, but not setting the world on fire. For instance, let's look at some older Fleetwood Mac. And I'm not talking about like Rhiannon or Don't Stop. I'm talking about Sentimental Lady. This is an old Fleetwood Mac track. And if we skip into the middle of this one and start playing it. So this was the hit for this record, Bare Trees. It's kind of dark, it's kind of mellow. Interestingly, when the guy sings, and this was a primary vocalist at the time, but they didn't stay with Danny Kirwan. But when he sings, it lights up a little tiny bit. But mostly it's just kind of sitting there being mellow. It's not doing all that much. Now you bounce over to, for instance, let's see what would be a good example of that. This is probably a pretty good example of that. Fleetwood Mac continued to be sort of on the darker side, so they don't really, their stuff doesn't really blow up with hit record sound nearly as much as something like Def Leppard. But you can see that even though it's not lighting up in the top range of the dynamic range, this is Fleetwood Mac's Don't Stop. And there is a lot of sort of the texture and body of their sound is working in the lower dynamic ranges to sound harmonious and good. And there's a lot of variation. There's a lot of scatter in here. And so this is don't stop thinking about tomorrow. Don't stop. It'll soon be here. And this is basically showing just as much hit record sound potential as it should because it was a hit. It's just voiced in a completely different way than like your heavy rock stuff. Whereas if we look at something like, for instance, Foreigner Feels Like the First Time, that is like another Mutt Lange, if I'm not mistaken. I might be mistaken, but I think that is another Mutt Lange. And that's very 80s, but it's loaded with energy and is kind of, it's a noisy track in its way. It's bright. And so this Foreigner track, I honestly don't think musically this is that great of a song, but the production is exceptional. If I can, I'll do an evergreens of this, and you'll be able to hear what this actually sounds like, fed straight through to the audio. And it's a frickin' Jackson Pollock painting here in blue. Blue is what signifies this is really lighting up the score as far as sounding like a hit record. And the meter tells the story. Like, none of my stuff was doing this. This is Mutt Lange doing this. Again, we can go back to the I think the pre-chorus to Photograph, there's a vocal scream in here. So there's Def Leppard going on. Or maybe it was this section. In case you can see that Def Leppard rocking out and doing their thing. They're playing the last chorus of Photograph. And this is a Mutt Lange production. And this is what Mutt Lange does. Everything is sculpted and balanced in such a way that the peak energy is extremely high. It's 6 dB, 12 dB, 18 dB down. All of his drum peaks go up to 12 dB and no hotter. All of the body of the sound goes up to 18 dB and no hotter, and all of the peaks are pretty much constantly maxing out at any given moment. Let's see if this is the part that I was talking about. So there will be a moment where I think it will change to the scream. Yeah, that would be it. But if you're interested in seeing a vocal light up the hit record meter, we need look no further than Journey. Don't Stop Believin'. Even though we can't see it, we can't hear it, but we should be able to see when Steve Perry sings. It's a mellow track, but observe how there will be little clusters of blue periodically as this starts taking off. Those little clusters of blue are literally Steve Perry singing. It also happens when Neil Schon plays certain guitar riffs, for what that's worth. We're not here to say, oh, yeah, this band is rubbish except for only Steve Perry. No. What we're saying is there are several sources of intense star quality that burst out of the sound, and they show up on this meter. And then as the band starts going, you start seeing more of a big name producer type behavior. But even without hearing it, you can watch what the meters do and see these little clusters of blue, which is the sound of the sonority of Steve Perry's voice, shown on a meter. It also registers on the zero cross meter as higher frequency, because he's singing a note that is around here rather than a bass note down here or a high frequency hiss that's up here. And in here somewhere is the bit where Neil Schon is like, and it might be that. But that's another place where it lights up in blue with the hit record sound. But that's the point that I'm making, is that some of this stuff is measurable. Some of this stuff is... and if you can measure it, that means you can adjust your mix to be more or less eliciting of those effects. You just have to have working peak energy. You can't just clip it all off, or this all goes away. And yeah, once the band is rocking away, everything is happening. But there's these tight little clusters. Like if we go back to here, the intro is very mellow. You can see the peak energy is coming across lower than the RMS energy. It's a little darker. It's not meant to capture all the attention. And then as we go, we will begin to see little hints of something happening, including little clusters like this, spots like that. Individual syllables don't necessarily take up that much space on this meter. And here it's starting to really light up. You took the mid-right train going anywhere. Might just be these lines, these blue lines, are literally Steve Perry singing, shown on a meter as being a star quality sound. That's what makes this kind of stuff interesting to me. Here we got separate ways. Let's see how that one registers, because I'm not sure I've even looked at that one using this newer version of the meter. Clearly the intro was doing well for itself in that way. This is not the easiest thing to explain, but what I'm trying to do is make it so that it is drawing pictures for you that show you what to do. Also, separate ways is a little brighter, although it's produced enough that it's not actually blowing away the high frequencies all that much. But this is where stuff is really obviously kicking in. And it's a dense enough mix that I'm not sure if Steve is showing up. We'll be able to see that by the way different things contrast with each other. This could be an S, this could be a cymbal crash, a variety of things it could be. These are going to be Steve Perry singing with the sonority that he has going on. When he just opens up, the top of his voice opens up and it just resonates right through everybody in the stadium, these are the moments that do that. And it is a matter of balancing out peak energy over RMS, and it's all about the peaks, and it's also all about the way that the peaks interact with the slew, meaning that high frequencies have a lot to do with it, and you can have not enough, and you can have too much. And if you have too much, it stops sounding like the hit record sound anymore. And it starts sounding like, I don't know, post-90s or whatever. But this kind of thing is how to do that style of, hey, check this out. Little Jackson 5. That is a very different sound from, Journey Separate Ways, which is very 80s. This is Jackson 5 from what, 1968, 7? I'm not exactly sure what year it came out. Turns out, the Jackson 5 I Want You Back registers star quality all over the place. And then same deal, you can see where Michael Jackson sings by the clusters of blue energy as the sonority kicks in and works out. You can basically spot places where Michael is singing on this graph. And even when he's not singing, it still sounds amazing. And that's also shown on the graph. And it is an extremely wide range. You've got a really wide range of frequency response on the zero cross meter. And all of the peak intensity is constantly being fully exercised. And the slew intensity matches the peak intensity really closely. This would be where Michael starts to really cut loose, if I'm not mistaken. Starts going, trying to live without your love. And that's a peak. That is the hottest point in the track. It's off of a real vinyl record, so that's literally part of the recording. His vocalizations are not that long here, but they make really intense blue spots in relevant places. Like this is probably him, high-pitched little voice. This is probably him. The darkness and intensity of the way that stuff registers. This is all I want, all I need, all I want. And there's a lot going on in this track, mind you, but this is how it all balances out. You can plainly see some similarities between this, which sounds very, very different from the 80s stuff, and the 80s stuff. The balances, the ranges are extremely similar. Hey, Sensenera. And here is our final outro, and it leaving you wanting more by just hitting you with this intense burst of all the good things in all of the audio places. And as it fades, it just gets better and better. And that's one of the glories of Motown. Whereas, let's compare something else that does not do the same thing. Here's Fairport Convention. This is Genesis Hall. This is great stuff, but this was not pop hit stuff as much. It's a very popular band. But they did not hit like Jackson 5 levels of fame. They did not hit like Fleetwood Mac era levels of fame. This is great stuff, but it is not blowing up with, you see how it's a little bit sparser. You can, and this is Genesis Hall. This is like one of the greatest tracks off of their first album. It's got its moments, but if you look at like Foreigner, if you look at like Def Leppard, that stuff is blowing up with energy all over the place, whereas this is kind of sitting and resting a little bit. It could be maybe a little brighter, it could be a little more compressed to have the intense production values that bring it into that kind of 80s zone. And you'll notice that even though it is darker, even though it's not really lighting up in quite the same way, the high frequency spikes are still coming out kind of a lot, and that doesn't happen off of like Mutt Lange Productions, things like that. Because these old dark sounding records can still put out surprising amounts of high frequencies. It's just not managed the same way. Or I can go to, I remember looking at this one and being like, this is a great song, and yet it's not showing up. The Deserter off of Legion Leaf, which is one of Fairport Convention's biggest records. But listening to it, it's pretty relaxed, it's pretty chill, and you kind of settle into it, but it doesn't grab you in the way that the super pop hit records do. And that shows. This is not a bad record. This is not a bad mix. But it is not showing star quality in the way that some of that 80s stuff, or indeed, like Dark Side of the Moon, sold a lot more than this. This is not putting up Dark Side of the Moon metrics. And it shows you why. It shows you that, like, the volume, although it's a fairly full sound, right? This is more RMS loudness than some of that Mutt Lange stuff. This is stretching up to nearly, 12 dB down, whereas some of the Mutt Lange 80s stuff or the Trevor Horn 80s stuff would not go louder than 18 dB. And here this is, the drums are hitting louder than on the Mutt Lange stuff. And yet it's not making it because the peak energy is not following through. The peak energy is not reaching up enough. It's just sort of the body of it, and it's a little dull. Not quite as much going on there. And then the slew energy is very restrained. It's always a lot darker than the peaks are describing. And whenever stuff is just all really clustered near this line, which represents 200 hertz, that means that it's all very mid-rangey as well, and that's part of it. And there's some good solid points of like sonority and resonance that come through here. And it's a great song. This is an excellent song. The singing is ravishing and beautiful, but it's not a great mix. Whereas if you look at, for instance, here's a Billy Joel song, Moving Out. And you immediately see lots of energy, and you immediately see just how quiet, like well below 18 dB down, closer to 24 dB down. This is that kind of late 70s, early 80s mix that to me says DBX. I think this is the DBX noise reduction system in play because of a certain thing that it does on the dynamic spikes of the kick drums, of the percussion. It has this way of being able to exaggerate that wildly. I will do evergreens where you actually get to hear this as soon as I can. There's so many things to work on. But this is Billy Joel's Moving Out. This part is where it goes giving you a heart attack, That's the hook. You can see the hook because it turns blue. And you can see the groove by how intense those dynamic spikes are. Again, I call this a DBX style recording. I would be shocked if they were not using DBX on this, because there's a bunch of other recordings that have this wildly exaggerated dynamics, and they all seem to have the same characteristics, and they even have weird, funky. There's the ak again. That hook in the song, gonna give you a heart attack, jumps right out. It gets loud there and it gets bright there, and that's the part that sticks with you. And you can see it on the meter. You can see it lighting up there, becoming darker, turning into a blue color. But all of it is throwing all kinds of energy everywhere, and it's filling up the entire range of the sound up to the top like 2 or 3 dB. Normally you would clip all of this off, which would be a terrible mistake. because this is where the soul of the song is. But you probably don't need the percussion hits to be as loud as this. You want these peaks to be covered. You don't need all these other peaks to be that much louder than everything else. Here is another Billy Joel song, The Stranger. And this, again, I think this is dBx. The beginning is so quiet. These are 6 dB lines. 6, 12, 18, 24, 30, 36 dB down. Try doing something where your RMS levels start out at 36 dB down in the modern day and see how far you get. It's crazy. But this is what it is. And you can also see, interestingly, that we've got some, it's lighting up in certain ways, saying like this is a good balance, because that's not relevant to, not only loud counts. This is a moment where it's a quiet moment that still sounds like it has star quality, even though it's that much quieter than everything else. It balanced, it fit. The tonal balance and everything was good. And then here is The Stranger kicking in, the full band section, and you can see that immediately there we are. The mix of this is just about perfect. It cuts in, and then boom. And then you can plainly see the part where that riff continues, and the voice comes in over the top of it, and the two things stack on top of each other. This is where they stack on top of each other. He starts singing, and the riffs are still going. And then they stop here, and this is him singing now. So they overlap, and there is enough dynamic range to cover the overlap. But notice how the dynamic peaks, the little dots up here, are still there on either side of the stack up. The stack up is not pushing the peaks that far beyond anything else. The stack up is just an arrangement thing where it gets much denser, but the peak energy is there throughout, constantly going. Never actually slacks. It's always something happening up there. And let me see now. Before moving on to other things, maybe there's something else I can show. I can show another example of not hitting hit record sound even though it's a great track. This is James Taylor's Fire and Rain. So this is a great song, and this is a hit song, and this is not a hit record mix. It's really dark. It's really dark and really mellow and kind of really quiet. And you do still see little moments where it's like, oh yeah, something is happening here. But this guy doesn't belt, this guy doesn't project, and the mix is not set up to be overwhelming in that way. And so you have a hit record that doesn't obey hit record sound rules. Those are the big peaks that you're seeing are like kettle drums coming in, the tom-toms coming in. And then at no point does it reach for the kind of intensity that you normally see in hit records, because this is not following the same rules. This is like the chill out music. This is where everything is very laid back, which is also represented by the way in which the zero cross is this just cloud down here. And it's never hovering around this line, which is sort of the overly 60s sounding, retro sounding line that's all mid-rangey. Instead, there's a fullness that's always present here. And half of the time when you do see a blue spot where sonority is happening, it's happening in the bass. You can look at this meter to see at what point did the sonority hit. And when it's like Steve Perry, it's up in the mid-range. But here, the cool moments in the production of this sit very low in frequency. So if you were doing something like this, you'd want to keep an eye out for whether you could make choices that cause moments of sonority, moments of like ear-catching sound, to lift down here rather than up here in this range. And you'll also notice there was a little high frequency spike. I'm not sure that was necessarily even a click or whatever. I think I went through and got rid of some clicks and things. And there we've got something happening that registered on the meter, but mostly this is just a very chill song. However, you can also have very chill songs. For instance, this one from Billy Joel. This is Just the Way You Are, but this is a much more recent recording. And this is like a 70s, 80s style thing. So the production of it is a lot more sophisticated. And it starts out mellow, but as it starts going, what you're going to see is that the breadth of sound texture expands outwards. And this is probably him starting to sing. You'll probably see moments, I don't remember what it is. I'll play this where you can hear it at some point on an Evergreens or something. But what you'll get here is it's all still very, very quiet. It's all like 6, 12, 18, 24, 30 dB down or more from peak. And you can see how the peaks are actually up here. Like, there's a peak up here. Even on, like, I Love You Just the Way You Are, we've got little percussive things popping up. And those are the drums. But the voice is the important part, and the voice is popping up here and there in these little clusters of energy like that. It could be voice, it could be a horn, and stuff like that is poking out of the otherwise very, very chill and bassy texture of the track, which is very warm and enveloping, and not what this meter is meant to register highly on. Although I suppose it could be fun to make it do that, but that would be silly. Add a control where it's like, yeah, dial it in for optimizing for James Taylor or optimizing for Def Leppard. Who knew that you could do that? The point being that these different things approach stuff in different ways. And there are consistent points where it registers, and you can see where it joins sonority with the high frequency energy, and it'll meld together into these moments. And yeah, this is Billy Joel, Just the Way You Are. This is a very mellow song, and you can pretty well see that that's what it's doing. Whereas if you compared that to, like, Foreigner, very quickly, it's not even that much louder. But what's making these is bright high frequency synthesized going. And this, of course, is them, singing, I would climb any mountain to get a hit record song, 'cause I know just the woman in you that gives me the inspiration for a hit record song. It's still in development, and you can try to download it and compile it. Like what you see here is on GitHub, so if you can get it to build, knock yourself out. I need help to make it be actually downloadable. But yeah, this is Foreigner. This is a really intense 80s bright hit record sound where there's a lot more going on than in something that is so laid back as Billy Joel's I Love You Just the Way You Are. And of course, we can also go to stuff like here is Nowhere Man by the Beatles. As long as I'm showing these without playing them, there's no reason I can't demonstrate the stuff where you can't get away with playing it anyway. So let's look at some Beatles. And that's the Beatles' Nowhere Man. And you'll notice that that's really bright. The middle one is showing just a whole bunch of stuff going on. Some of these things are S's. A bunch of them are just like percussion or whatever, anything going on. Plugin's not done yet, man. So this is a real Nowhere Man. This is a Beatles hit record, one of the biggest hit records off of the UK version of Rubber Soul, which revolutionized the industry. And this is what they did. Basically, this is what they did with compression. This is all about compression because they were mimicking the Byrds, and the Byrds were using incredibly intense compression at the time. So their people were able to go along with that and master that. But then if you go on to, for instance, Sgt. Pepper's Reprise, you'll notice an interesting thing. As you move onwards to the hittest of hit records, Sgt. Pepper, that blew everything up completely, there's some things to observe here. It's exactly the same kind of signature. It's a little bit more dense, maybe. This is very loud. And it's all very well balanced. But you notice something interesting about how the high frequencies no longer have stuff poking out all over the place. That gives it a more sophisticated and refined sound. When you have them blasting away like this, and everything is very bright and edgy, there's the occasional spike, as you can see. But on the whole, like, this is a picture of Sgt. Pepper's using the same meter as you saw for Nowhere Man. But on Sgt. Pepper's, their super high frequencies weren't poking out in the same way. It was balanced in such a way that that was no longer happening. And everything balances to produce this composite result that maximizes this particular behavior. And this is Sgt. Pepper's Reprise off of that album, which I've also got some other ones as well. Let's see now. Lovely Rita is also off of Sgt. Pepper's. It's also one of those ones where I couldn't even play it if you wanted me to, and so there's no reason not to do it now. And interestingly, as much as these are optimal, some of these tracks are more hit record sound than others. And they're not all the greatest songs in the world. They're just sitting in a place where the Beatles were writing years of producing records like this, and that's what got them to the extraordinary amount of success that they had. I remember some of the ones I was going to show. And so you've got stuff like this going on where the pattern they're producing here is, I would call that a typical tube record Beatles pattern. where the sonority comes through very strongly all over the place, but it's usually like up here, right? The sonority tends to be upper mid-range. It shows on the zero cross meter. That's what correlates the way that the highlighting is done. If you compared that to, for instance, something off of Abbey Road, which I might or might not have to, yeah, I'm going to have to normalize some of that. For instance, let's grab Come Together. And we're going to normalize that. And this is transistor beetles. And the difference between transistorized beetles and tube record beetles is that the transistorized beetles actually has more capacity for loud peaks than the tube beetles did. And so we're beginning to see a range of, remember how when we were looking at the stuff coming off of the tube records and it was all a cluster living up here? And now that they are working with the transistor hardware, you still have the same signatures. But Jeff Emmerich, the guy who was their engineer, is on record in his autobiography as saying, yeah, when we started working with the TG12345 console, which this is, it was like pulling teeth to get a good mix out of it because I just could not make it be as good as the old tube stuff was. And the songs were no worse. In some ways, I think the songs are better than the ones on Sgt. Pepper's. But Jeff struggled mightily to get the mixes to sound nearly as good as the old tube, the Red 30 whatever, or the Red 51 consoles. And you can see why. What we see here is here's all of our peak energy and stuff, and we've got the same compression and things going on for everything. But the dynamic spikes poke out way beyond everything else because the transistor is not soft clipping them. And the brightness spikes way beyond what the other ones does. So to have it be a comparable amount of brightness, the transients of this track stick way up beyond where they otherwise would. Whereas in the tube track, this is all compressed more, and this cloud of stuff down here would be sitting farther up. And there are technical ways of managing that or dealing with it, but at the time they didn't have any real way of dealing with it, and Jeff was basically stuck with making the best of how this new console sounded. And he would manipulate the tone controls and stuff, but the overall envelope of the sound was intractable. And so he did the best he could, and you got into stuff like this. I'm not exactly sure what was happening right here, but this is Jeff Emmerich taking the TG12345 console and trying to do the same stuff that was so easy back when they were doing like Nowhere Man or whatever. And it's just a cloud of loud tubey goodness that is loud and bright in all the right ways, whereas this stuff is technically a lot more accurate, but accurate is not always what you want. And then lastly, Beastie Boys. And you can see how the loudness of the tracks fluctuate around a great deal. This is old sampling. And one of the things about old sampling is it does not throw as much brightness as new stuff does. Hey, Fotis. And so we see the Beastie Boys showing a very like Beatlesy hit record sound picture off of this classic hip-hop album, Paul's Boutique. And when you listen to this, it does not sound like Beatles singing songs about Nowhere Man. It's like, but the hit record sound is much in evidence because of the way that it's all mixed and balanced among itself. And then they will pick, certain things will be this kind of sound, certain things will be them going to a different kind of sound. For instance, this is more loud and sonorous and something else is happening. They changed the tone of what they were doing. But bottom line is, according to the meter, Paul's Boutique is a hit record. And indeed, it was a seminal hip-hop record that changed everything. Yep, Dust Brothers, bingo. And we can even have a look at, again, since we're not actually playing these through, here is Nirvana off of CD. This is not Nirvana off of a vinyl record. This is Nirvana off of a CD. You can tell it's off of a CD because the brightness factor expands out quite wildly. But it's still like, this is what, an Andy Wallace mix? Same deal. This is Nirvana. This is Smells Like Teen Spirit. It all follows the same rules. And people gravitate to certain kinds of sounds and the way things are done. In this case, this is probably a chorus or getting louder or something. You'll also notice in this one, we've got little spikes of blue up at the loudest moments, which is another way of characterizing the, if you talking about a remaster of any of this stuff, any of the remasters will look like what I'll show you in a moment. In this is like 6, 12, 18, 24 dB down for parts of it. And the RMS loudness of the drums is 12 dB down most of the time. A little bit louder than 12 dB down. And you can see where the peak energy is. And you can also see where the kick drum attack is, because the kick drum attack is a little hyped. But it is not so hyped that it spikes upwards beyond where the RMS graph is. And that's something else that I'm going to use as a kind of guideline. Like if you wanted to make a 90s style sound, let your transient peaks poke through like this. Try to make them be all different shades of gray rather than only black, but let them poke through like this, but no higher than where the loudness is. And this is how you mix a Smells Like Teen Spirit and perhaps change the world. And this is how you mix a modern track. So yeah, maybe don't do this. And this is not bad music, but you can't hear it very well. Yeah, so maybe don't do this. This is modern work. You might not want to make your mix like this. I'm just saying. it might even hurt you going forwards, besides which all of the replay stuff will turn you down for doing this anyway. So it's not like you even really get to appreciate or enjoy it. Yeah, maybe don't do that. Foo Fighters can be completely awesome. Nothing wrong with the music. I mean, it's overblown, but so is The Who. Come on. But modern mixing is this. Maybe don't do this. I am learning how to... Here, I can play something else. Here is Dillinger Escape Plan. I love Dillinger Escape Plan, but I wish they didn't sound like this. You can see it's trying to be a mix that has good things going on. Yeah, and this isn't even their final... I don't think this is One of Us Is the Killer their final record? I don't think it was. No, it's not. Okay. Yeah, so this is One of Us. One of Us Is the Killer, and the red is the clipping. So yeah, if you think the other one was full of nasty clipping, this is literally just as full of nasty clipping. The height of the spike is how bright it is while it clips, but the red means it's clipping. No, content ID is for when I post a track for study like this all the way through with like white text across the top to explain whatever I want to explain, but it's the Beatles or something. Yeah, so like maybe don't do this. And it's not to say I haven't done this as well, because I have sometimes, although not as far as this. That top line is 6 dB. So modern stuff tends to assume that it must push everything beyond the 6 dB point at all times, or at least hover around it, and everything is lost. You have nothing left when you do that. So yeah, so that's Dillinger. Then when they drop out or do quieter things, here's a section where they do a quieter thing. I don't remember what this bit was, but it was a bit that is not as loud as everything else. Probably a mellower, bassier bit, but they're throwing a lot of bright frequency spikes in here. And then with this modern stuff, it's all about how soon you can get back to utterly obliteratedly loud. But this is what quiet in the modern day sounds like, which is the full range of other stuff. And when you start combining this with like streaming service replay gain to make stuff sit next to each other, you get no benefit from going this hard. You have these bursts of super intense, but it's just another form of losing everything. Not awesome. Compare that to, let's see. This is going to be Birthday by the Beatles, if I'm not mistaken. If I normalize that, there might or might not be some things that are actually pops or crackles, but those might simply be dynamics. And you know you can't play Beatles on the... So here's the White album. This is the album where they have never stopped reselling this. And it is the final tube console Beatles album. And this is like exactly the same as the Rubber Soul stuff, but even more expansive in terms of a wide range that is entirely filled with energy at all times. And all of this is peak energy. So yeah, here's the Beatles for you. Yep, this is birthday because that's the part where it breaks down. It goes chunka, 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 chunka. So Beatles playing Birthday for you off of the White Album. This is why they've been selling the White Album over and over again for like the last 50 years. Oh no, this is breaking new ground. Yeah, nobody else has this. Dynamic range meters don't track slew. Anything that did track slew wouldn't be tracking the relationship between peak energy and slew, which is what this is about. And if they did, they wouldn't be tracking a zero crossing meter, which is what shows you where in the frequency range that energy lives. So this is the White Album. If you want to be as revolutionary in making hit records as the Beatles, do it like this. And again, the Beatles weren't able to do it like this once they lost the tube consoles. And so one of the things I'd like to do is be able to, say, take this and then take it into the 70s and 80s by replicating this same behavior with the even distribution of energy sitting in this way and matching the slew, but with an arbitrarily small amount of RMS loudness. Like, take it all the way down to the 80s levels where the peaks are just completely enormous, and then have the cloud of peak energy and slew energy be this densely filling the area. That, I think, would give you a real hit record sound. And then that's when the Beatles stopped going chunka, 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 chunka. And then they burst into the, yes, we're going to a party with all of the instruments cranking away at full crank, which is why the cloud looks like this. The cloud looks like this with nothing in here because everything is dense and saturated. And then this is where I would like you to dance, take a cha-cha-cha chance. And here, it opens up a little bit down here. There's a little bit more of a variation going on. Whereas with this, they were just, and the sound never stops. And there's never a space to breathe. But it's all bassy. It's not like high frequencies. You can see that here. And then here you see that the peak energy is kind of all over the place because that grooving is largely bassy energy. So you get a full range of slew going on there. And then when they bust into the I would like you to dance, take a cha-cha-cha chance, there is a piano that comes in. The dynamics become a lot more spiky. You got that going on. And the slews also cover a fuller range and bounce around more like that. And you'll notice that all the slews go like right up to the top edge and not a bit beyond. There is a real well-controlled range of energies that you can put into a record like this in order to have it be, your hit record sound. And I'm going to have to close this without saving that. Oh, this is amusing. I think it's all too much. I'm going to briefly glimpse it just to hear what I've got. Oh, in order to do that, I'm going to have to... Okay, so that's amusing. So this is off a Yellow Submarine. This is the Beatles melting down in too much acid. And ask Syd Barrett if you don't believe there's such a thing as too much acid. Copy, new, make a new thing, paste. And now we're going to normalize that. That was not what I said I was going to do. We're going to normalize that rather than automatically just meter it. So here's the Beatles blasting away in the era of Magical Mystery Tour. So what was happening at this time was they were not writing as good songs because they were frying their brains like crazy and being enormous hippies and just freaking out. But you'll notice that the long-suffering sound engineers who were working with them were being demanded to make amazing stuff out of this. And one thing about what the Beatles were doing is that they were pulling out all the stops. There was no limit to how hard they were willing to sing, how hard they were willing to play, the loudness of how loud the drums were being played, all of that stuff. Like, those spikes are probably snare drum hits. And as a result, this is George Harrison's "It's all too much for me to take, the love that's shining all around me." But they're rocking it out. A huge intensity pouring out of this. The thing is, they were doing that while making the Magical Mystery Tour movie, which did not go over well with people. And they thought it was going to be great. They were like, oh my God, we're setting the world on fire. We're making the most amazing music ever. Thing is, the content of this music was not supporting the amount of apparent importance that was pouring out of the grooves from it. Like, it was all, it's all too much. That is literally the song that we're looking at and would be listening to is It's All Too Much by George Harrison. This was not considered a hit, but they pulled out all the stops, and the production is beyond intense. The production of this is just straight up overwhelming. It doesn't let up. It's like that Oasis album, Be Here Now, where very similarly to this era of the Beatles, just everything was louder than everything else. Everything was turned up all the way. Everything was fighting with everything else in the sound. And that's what that looks like. This would be a picture of overproduction, of just pushing everything so hard that it's completely overwhelming. Only way you could make it even more so is by peak limiting off just the top edge there so that it was constantly just bursting forth at any given moment. And you could do that. You could push this in volume just a tiny bit so that it was even more explosive and see what you got. And that would make these things poking out in the slew meter even more intense. And it would be pretty well, it would be kind of unlistenable because everything would become, the entire cloud would be sitting in the 0 to 6 dB down range and all maximum sonority and brightness and loudness at all times. And just, it becomes exhausting. Whereas if you let the cloud expand so that your RMS loudness is a little less quiet than this, because this is pushing the limits of what's listenable. If they had it all, because this is also all incredibly compressed. It's all just exploding in every direction. If they had it pushed so that this part went literally up to probably the 12 dB down mark without ever wavering from it, that would be your picture of just unbearable overproduction, because this is leaning in that direction already. That said, I quite look forward to doing an Evergreens on Hey Bulldog. Hey Bulldog is an amazing song. But this I have not even gone through and cleaned up the clicks and pops and stuff. Like, what I'll be doing is stuff like this. When I do this, I have to go through and find all the bits where that might be a real sonic feature. This is not. You can see that this is a pop. It's a record pop. And it's way louder than everything else. So what I end up having to do is going in and literally deleting all of these bits. They're so quick that you can't really hear when you do that. But I got to do that by hand. And that's very tiresome. Like, here's another. Yeah, so I have to edit out all of this kind of stuff in order to be able to make some of these vinyl records presentable. But yeah. So let's actually stop with that for the moment. I feel like I want to make a final cup of coffee for the day and then get back to work. So what I'll do is pick something to put on. Also, I need to visit the restroom again. I'll be doing that momentarily. So let's set this up with that same meter that you've been seeing, but in this case, you'll be able to hear it as I go off and do my boring human things. And I'll be right back. But not before I take a moment and check this for what might be a good period. Okay, that's going to be bright as hell. But it kind of sounds like that might be good. Okay, let's see what the meter makes of this. I'm going to play it while I go off and make another cup of coffee, etc. And that's a jam. This is Batic Erotic. This was a live performance. And it's mine, so I can play it all I want. And let's see what this looks like on the meter. I'm going to guess right away that it's going to be louder than it needs to be, and that the high frequencies are going to be brighter than they need to be. But let's see how much. Actually not that bad. Right. I had a feeling that was going to be a jam. And back in a bit. Wow, look at that. Whatever it was doing, it was showing up pretty good on the meter. Damn. Let me take a moment to hear what the heck that was over the speakers. That was a minute ago. So whatever it was doing this. Or possibly this. Yeah, there we go. Oh, this isn't on Bandcamp yet. Oh God. Yeah, this is nuts. Well, I should put it on a Bandcamp then, clearly. But yeah, this is not a Bandcamp. This was an old gem of modular synths. That's quite something. So how those modular samples, how those vocal samples are being made is radio music again. It is radio music being re-triggered a lot. And it's probably, when it's doing the stuttery crazy stuff, what it's doing is it's bouncing back and forth between different tracks. I made long extended tracks, which I can probably even show you. Like, I can show you how this was done, if I'm clever about it. So I'm thinking I may or may not have that particularly handy. That's not going to be the one. Yeah, I probably have that on the CDR, BDR. I burned it to a desk, in other words. So that's in my samples, but what else do I have? I have studio synths. In studio synths, I can look up things like Music Thing Modular, and do I have that's an amen break? Radio music sounds stored away somewhere. Nope. Nope, that is software. That's how the hardware was done. I can tell you, but I guess I can't show you. Or I'd have to kill you. No, I mean, I can't show you because I can't find the damn things. Probably because they take up too much space. Oh, or I say that, but they are literally right here next to me. And they run off of SD cards. And I have a little SanDisk thing through which I can plug those SD cards into this literal computer. Bear with me for a second. We're on it. So here's my first one here. This might be worth the effort, or it might not. And this is how a radio music is organized inside itself, is with these little folders. And the folders have things like this. This is a manipulated recording from old supermarket background music records. The Kresge department store had this going on in like the 40s or 50s or something. And so my 0 channel is multiple ones like that. Here's how those voices were made.
Welcome, Tommy. They may not always have the minimalism. I really stick with it most of the time. But hey, Tony, I may very well end up learning to do VST.
This is one track,
and switching over to that for the purpose of doing other plugins that have the graphics and stuff. Because I've done stuff like that before.
Oh, the Kresge thing is archive.org, if I remember correctly. It's just a sort of public archive site. And when I play that stuff, I chop it up so radically that it's not the original music anyhow. So it's kind of like old library music. Yeah, or of course the Caretaker. But how I did that vocal stuff is like this.
I've never had a solution that works really well for me as far as doing VSTs and...
You see how this is literally me on stream.
Comprehensible and working on really...
But what happened was I took multiple hour-long streams, right, and chopped them up into sections, and then I ran a particular I think it's Twisted Wave that I did this in, which is what's currently open. Let's see if I can further demonstrate how that works. I'll show you literally what I did. And I made this many instances that are all about the same length. They're all roughly the same lengths, because what the radio music does is it lets you snap back and forth between any one of these based on what CV you're putting into it at the same position. It just jumps into whatever that file is at whatever position you tell it to be. And you can scan around among the positions, and you can scan around among the files. And so the reason they call it radio music is because normally you'd have like, this would be one thing, this would be another thing, and you would snap back and forth between them and make an effect like changing the channels on a radio. But these are all the same, except they're not. I also seem to have cut them down a little bit in level to keep them not from being distorty.
Going on. So I got GitHub up, and I've been having a bunch of interesting ideas and traveling with my computer programmer brother who can tell you how to do things. And S, I believe. Yep. So it's about 2 generations old, but then it's about.
So you can bounce around.
We have to just program more, and that makes concerns. It's a question. Isn't we had a noise set up at Nerdly computers to get through now. David. I'll also tell you why inside there. My paper. I'll also tell you why a local effects in between the two. Microphone etched on both doing this in where you recording the right thing. Input on fine.
So it's like that, but if you switch to exactly the same spot each time, what will happen is it will roughly loop the thing, much like with just a single sound, you get stuff like that. But if it bounced around among a bunch of different channels, you get a wilder thing going on. And if you took that and speeded it up and slowed it down and did weird things, you'd get what I was doing in Batic Erotic. It's literally done using this.
I
can go up in pitch or down or whatever. And it's just really arbitrary. But the way I made these, if I am not mistaken, yeah, Twisted Wave, select detect silences. Expert mode. Now I can have more of a range. And when I change the, you see what's happening with this? If the threshold is minus 20 dB, and we can change the minimum silence duration or maximum silence duration. Like we can make the minimum silence very small, but it not be as loud. Left padding, we can have no padding and no padding. Minimum sound duration also has an effect. We can change it like this. And then we can place markers or select silences or select sounds or delete the silences. And this is what I did. The way I got this file in the first place was by taking long streams of me talking like this and using this very operation, right? This very thing. And now I'm doing it even more so. I hit apply, and now it's all squished together even more.
Chaotic. Oh, like I'm being told things like analytics and stuff. And it's like, do you want to share data with Apple? Well, I tell you, I have this for you about data. It's having me set up all of crap that I don't really. Oh no, everything's going insane. Excuse me. I think this crap is going to just have to sit around. Look, enter all these password things. I've had this for a while, and it doesn't run.
See how it doesn't take a breath or stop? Now let's keep going. We'll undo that bit, and then we'll do even more. Twisted Wave, select detect silences. Minimum sound duration, even less. You'll notice that if it is minimum sound duration is longer, then it has to keep a chunk. But if the minimum sound duration and silence duration are tiny, then we get really aggressive with it. And then if the threshold, the bigger the threshold is, the more gets removed. Like we're seeing everything get removed now, or everything get retained now. And so you zoom in until we've scrunched out a lot of it. Apply that, and now we have an absolute sausage. And it is unintelligible. And so now clearly what we must do is make that into stereo and throw a reverb on it. And pipe it into, well, in a moment I will pipe it into the stream and you can enjoy it, but I gotta set it up first. So let's see. And then we can use Airwindows Consolidated for it. All plugins. Yeah, let's do Galactic too. And you get something like this. Oh no, that was far too loud. Hang on a second. See, is that gonna do that? Okay, that's better. And that comes out of a noise like this. And it's made by taking a noise like this.
So now I have a pen and paper, and I'm going to write FFT on it because that's the next thing that I'll talk about. I'll explain that. But yeah, the reason things are a little chaotic is that things are a little chaotic.
Which originally had a lot more space in it because it was a live recording of me talking kind of like this, except for into the back when I had like the older headphones with a little wire with an electret mic on it that was powered off of the headphone jack of a laptop, possibly this very retro laptop and possibly not. But when I was doing that, I captured a bunch of those recordings as just the full length of my stream, and I was talking to people
SoundCloud of my
just like this.
Just because I have taken, and I'm reminding myself of it now, I have taken
and
to do
it wasn't the best sound, but it was a pretty clean sound.
My input on our talk live streams, because it's the time when I'm doing this talking into my little headset microphone. My paper and pens are good enough for this. I'm recording it because once I get caught up in talking to people, I forget I'm recording. And so, actually, you know, I have access to a chalkboard.
So what's going on there is this is exactly what I recorded, and it's just like me talking now. It is the direct mic feed rather than, you know, I captured it in, looks like this is 44.1K. I might have captured it in 48K. I captured it somehow while making a stream. And then I used that delete silences thing that Twisted Wave has, and I took out all the breaths, I took out all the pauses, so that there's constantly sound happening. And then you feed this into the radio music.
The combined bus, if the bus was high, whereas if you...
And if it swaps randomly around,
continue to affect
among these things, you wind up with the kind of gibberish that I was working with in that track, which of course gives you that's the voice, that's me. Boy, I kept that going for a while, didn't I? There it is again. This is a really good example. And that's it being re-triggered really fast. That is just the voice again. Probably you can. Here's a good example. I may well have had the echo device on there too, though. Yeah, that would have been the Erica synths delay. You can hear little glimpses of it. Let's see if there's a good spot that I can loop a little bit. So this is done doing that technique I was telling you about. So you do something like this. And those sounds basically come from this kind of thing.
And again, I have not used it on anything. And it's possible that I'll think of something.
It's just bouncing around among all these options very quickly. These are all loaded up as part of the radio music, and you feed CV in and it can swap among these things very rapidly. You can even see which days they are recorded on. These are all from 2019. There's 4 from March 11th, April 1st, so it's April Fools, 4 from April Fools, 4 from April 8th, 4 from April 15th, and 4 from April 22nd. So let's see, like about 5 different days. And that's how that's done. They're all edited up until there's constantly a sound happening at all times. And then you just sort of bounce around among them. And we've got other stuff, like, for instance, that is a drum kit that's actually me, but it's meant to be made into sort of amen break type stuff. And then you can re-speed them. You can play them at different pitches, of course. But that's the guts of doing an amen break type stuff the way I might do it. And yet it's not the amen break because it's me playing it. And you can tell that I'm not as good a drummer as the real guy. But you can do somewhat similar things with it. And there you have it. That's how that stuff's done. Let me put it back before I forget that I took it out. Start up the synth without it. Don't mind me fussing with stuff. There we go. That's better. That's not. That's better. This goes in here. Need to point it this way. And that should be good. So yeah, I'm able to demonstrate how to do some of those things that are mysterious outbursts of noise. And then, yeah, that stuff, it is on a Teensy. So that's basically a 12-bit, very primitive DAC. And it only exists on that particular form of Teensy, so it's a great tragedy that they don't make them anymore. I'm very disappointed about that. And yeah, you can dither the audio results to 12-bit, which is what would have happened to get into playback properly. And yeah, which makes it play back better, like you heard in the actual mix, is that coming out of a radio music, namely a Teensy processor. I gotta say, I should talk to the guy from Music Thing Modular and be like, when are you going to come up with a current day version of the radio music that'll work? Because that was such a, like, let me count them. 1, 2, 3, 4, 5, 6. At least 6, if not more. Do I have more? I've got 6 of these freaking things. That's how cool they are. And I had to build them all by hand. And they're somewhat hot-rodded. I'm using like custom capacitors and things in them, but mostly they're just a Music Thing Modular radio music. He has a real knack for being able to make incredible little devices that you can assemble yourself with a soldering iron. And that's all based off of an older version of the Teensy, which is like an Arduino type thing with its own little designs. And that particular one had its own sort of pseudo 12-bit analog out that you could use audio code to drive. So you can send, notes and things through it. And the tone of it is just a wonderful thing. The tone of it is just a wonderful. Well, that's the problem, Crappy Blonde. Like, you would buy. I mean, you can buy this cat. I love talking about this guy. He doesn't even pay me anything. I figure that I earn so little money and am so small time that I can endorse things because I love them, and that's legit. Like, I have no reason not to endorse, for instance, Surge XC now because I think it's the coolest thing ever, and they also help me out doing stuff. But this is a Music Thing modular control surface that is tiny. It's the size of a credit card, but much thicker than a credit card. And you purchase it from Funk UK, which is a company that sells a bunch of kit things like that. Funk has all manner of kits and stuff. Thing is, you can't purchase radio music kits anymore because you can't get the processor that it runs on anymore because they stopped making the things, and that is deeply frustrating to me. There's newer versions of Teensies. Like, they came out with newer, faster, more efficient ones, but that no longer have that 12-bit output. So now I've got 6 radio musics, and I always, with the work that I did on those, I always intended that this is also like open source code. My chord organ hacks to make that work differently. I always intended for that to be something that was accessible to people who were willing to build stuff out from kits. And you could build a radio music and then install my software on it and do the same generative music stuff that I was doing. And I put out the code, and it's available. But now you can't build them because you can't get the Teensy microprocessors for it. Jonathan, this is just for a kind of Teensy microprocessor that you can no longer buy. Fotis is talking about something that I did specifically for those little modular synthesizer parts that I was talking about and that I was showing. So, no, Thunk. Just a moment. I will type it. That is absolutely something I can do. Thunk, 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 thunk. That's an unusual enough word that a simple search for that will probably give you that. And that is the storefront, where they sell lots of different people that make lots of different kits. The one that I am most fond of is Music Thing Modular. I just enjoy the hell out of that. Although building nonlinear circuit stuff is also very exciting. I really need more nonlinear circuit stuff. I also need more Bastel stuff. I am tempted to... Do you want to just indulge me in some silliness? We could just do some silliness. Because I just spent the morning adding to the incredible queue that I have of finished plugins, and I've just finished Cersley 3, and so all I got to do is port that to VST, and then that'll also be waiting in line to come out. I've got distance, I've got discontinuity, like I've got stuff set up for months. I don't really need to build more plugins. But what maybe I could do, as long as we're fooling around, I'm wondering about that, Jonathan. I have my heart set on going to a con at some point and being able to do this kind of thing, but with more than one of these. As long as we're talking about how you can't get Teensy anymore, you can still get these. And I may just be able to, yep, there we go. Plug this in and turn this on, and terrible things might happen. Okay, that's too much bass. Okay, So these are Bastel Castles. And so what I have done here is wired this up. It's too loud, I'll turn it down. So this can be powered off of a USB cable, and this has a USB charging cable in it. So you take one of these, and you take these, and you have a jam session device. And you can do this. How can I make this be visible? And the neat thing about these is that they are not made out of teensies. They're made out of a thing called an AT Tiny that you can still get. I'm going to see if I can get this to kick in. Ooh, I bet I simply haven't got it patched in. That's what. Yeah. Now I have two of these connected together. So now the one on the top is doing the bass, and the one on the bottom is doing this percussive stuff. So what's happening as this does its work, let's see how we can set these. That's actually no good. Boy, does it have to be quiet. The lows really come through, don't they? So the low speed is doing this. And we connect this together, and then the output of it goes into the output. And that's at a different speed. And they each have their own sort of delays. And you can modulate them differently. And then the tempo of the faster stuff is this. And it's being re-triggered by the clock of this one each time it goes around. So you can get them all to kind of work together with each other. And we get all this funky, scratchy music going on. I wonder what I see something that is obscuring, but I don't know why it's obscuring. Is it the corner of the... It is. Fancy that. How did I end up with the screen covering my screen? Oh, no matter. It's fine. And we could also take the scratching noise and replace it with a oscillator of some kind. Oh, nope, that is the re-trigger going into that. I did the wrong thing. So let's put that back. So you can also take the other thing and put it into this. This is also Bastel Castle. And then you can take the clock out and do other stuff. And since this is a mobile party speaker, you could take it out into a field and do this. So that's why things like teensies and such are cool, is because you can use them to build crazy things like that. And that's one of the things I'm eagerly looking forward to playing with when I have the chance, as always. Because all the stuff that you heard, teensies used to cost like what, $16 or so, or less? But they don't make the ones that I used for the modular anymore. But those noises weren't coming off of teensies. Those noises were coming off of Bastel Castles, which is basically nothing but a bunch of little tiny potentiometers and a few resistors and printed circuit board and stuff. And each of those little squares of madness is 2 AT-tiny microprocessors, each programmed in a different way, by Bastel, who make their code available online, so you can get your own AT-tinies and program them in such a way that they will do those things. And AT-tinies can be had in through-hole designs, so you can build them on like a piece of perf board or whatever, which is something that you can do. And I have because each AT-tiny will cost you like $1. They're like a tiny 8-bit microprocessor that costs about $1. And Bastel have come up with a bunch of really cool things to do with them. And as I just demonstrated, you can hook batches of these together with each other. You can power them all off of a USB, meaning that you can carry around one of those party speakers with that kind of madness going as you walk around, or in any other way, any other way that you can make audio come out and that you can provide USB power. You can make that work. And so that just fills me with nothing but delight, I gotta say. That is the funnest thing. I love that sound too, as Fotis said. But the thing is, the stuff that I do with my modular synthesizer and the generative music stuff that I'm doing with those music thing modular radio musics, the stuff that I was demonstrating, you can't do because you can't get the microprocessor that it's based on anymore. But you can still get AT-tinies, and they are even cheaper than teensies, and so I am just sort of filled with delight at the idea of building something like that. There's just a lot to it, but I mean, it's like the circuitry is not what you would call hard. In fact, I think I might actually even be able to show you. Yeah. This is the schematic for what that thing was. What we're looking at is the power thing. Here's USB power that comes in. We've got solder pad for battery. It has little battery cases because it's designed to run only on batteries. And then these are each AT-tinies. They are programmed using a little tiny doohickey that plugs into USB too. And there's just like 8 pins. It's this tiny little chip. And you just plug it into like stuff. I'm trying to figure out what this is. Is this a switch or? No, that is just, these are sockets. What you couldn't see because it was too small is that all of these lines just go out through, your occasional resistor. Here's a resistor, here's a capacitor. and they go out to these various things. These are just pin sockets. You can plug wires into them, and it's all designed in such a way. And I don't know if these capacitors are necessary. Here's your audio jack, so it's filtered, but it's just the output of a crazy little chip. So you could just leave it like sharp edged. You can plainly see that here's where the output of the thing comes out, and it goes through a single resistor, which keeps it from burning out if you short circuit it. It's all designed to not die if you short circuit it. And you don't necessarily need this capacitor. You could have it be really edgy and sharp. And then wave also connects to audio jack TRS. And that's where the sound output comes from. And yeah, we've got all of this stuff going on. Some of these things, like the arrow looking things, are connected to something. Like, for instance, where it says WS1 mix, that means this wire that goes to pin 2 goes to right here. And there's a couple of diodes that stop it from burning out if you do it wrong. And there's a 5 volt there, so the 5 volt can go to that. And then there's a 100K resistor, and you can do various stuff, and it's another place to plug stuff in. And the 100K resistor is, let's see, and this is, B100K 25 watt. That is a potentiometer. This is one of the knobs. Well, I've actually got an enormous quantity of dual 50K slide pots that are quite large rather than the incredibly tiny stuff there. So it's not impossible to wire all of this stuff up and go with it. That is the sort of thing that one might do. And it's just such fun fussing around with it. Like, once you get stuff like that working, if you can do things like, take the little chip, program it with the Bastel software so that it's doing that oscillator or it's doing that drum machine. Yes, that's a drum machine. It's a little weird, but it's still a drum machine. Figure out how to feed the right voltages into it or out of it. If you break it, it costs $1. It doesn't really matter. And just sort of run amok. You heard what I was doing with it. It's great fun. And that's the thing to do when you're not programming plugins. And that said, I'm going to go back to a little more programming plugins because it's 1:38 in the afternoon, and I can probably do a little more about that. Plus, I'm starting to get questions again, and so I would like to also answer those. So let's see. First, I'm going to move this over so I don't bump it by mistake or something. And I'm going to drag this over for when I want to use it. Maybe pull in the audio cable for it. But yeah, so Crappy Blonde asks, what do you think about audio interfaces? What's the most accurate and transparent and has good signal-to-noise performance, and so on? You're talking cost no object, so I'm currently using Lavry, and I'm happy with Lavry. That said, when you get a little bit more normal, I am a Mac user, and so I'm happy with Motu. I've got a Motu 16A that's working nicely. The only way I'm able to get better sound than it is by going to the full-on Lavry. And if you were on PC, RME is basically the equivalent to Motu on the Mac, of just very well supported and considered to be reliable and considered to basically work. The difference between Lavry and Motu is not really about signal-to-noise performance, nor is it about specs. The Motu will actually do 192K, and my Lavries will only do 96, but the Lavries do 96 better than the Motu does 192. And that's more or less my ideal, that's what I consider to be an optimal sample rate for musical purposes, for sound purposes. So let's see. Where are we at? I don't think you gain anything by doing a 32-bit floating point recording audio interface. I don't think you gain anything from doing that. I think once you start working with and processing stuff, that's when I go to double precision and stay there. But as you are capturing, the stuff that people always talk about processing becomes true for the raw audio data. Like, and I'm using Lavry Blacks, like DA10, 8010. There's fancier Lavries. These are completely fine. They're still fairly upscale. They're not the fanciest Lavries you could possibly have, and I only have 2 stereo ones. All of my monitoring is the DA10. It's dead reliable, by the way, and I've got them built into a little rack system, which you have to buy special parts to do. As far as 32-bit floating point recording audio interfaces, the converter will clip at some point. The fact that the format could clip is basically irrelevant. When you are capturing to, for instance, your normal way of going about things would be a 24-bit capture rather than a 32-bit floating point. When you capture to a 24-bit capture as a single stage, that's technically more resolution than you need. What ends up happening with the 32-bit processing is that you keep running into quantization at that 24-bit level in the loudest 60 dB of your sound so often that it adds up. Because when you're running on 32-bit float, every little calculation that you ever do is going to incur that. So you have to run into it like many thousands of times to ever notice. This is not the same thing as like hitting something with unquantized 16-bit conversion. 24-bit is enough for capture because it's being applied once. And you don't need the increased resolution of 32-bit float down in the quiet areas because just like people always talk about, like you'll get a Dan Worrell or whatever talking about it, just like people always talk about, the thermal noise of the resistors in your interface is going to be more than that. So 32-bit floating point or better, like double precision, is for calculating with and not generating digital problems. The capture, I do not think you need 32-bit floating point for capture. So the emergence of 32-bit floating point recording audio interfaces, that's fine. There's nothing broken about that. There's nothing wrong with it. It's fine. It's not going to get you anything over 24-bit capture. The kind of interface that you have is going to have way more of an effect. Like my Lavry is going to sound better at 24-bit than some of these ones that are, for instance, 32-bit, if the associated hardware with the 32-bit interface isn't as good as that of the Lavry. So yeah, I mean, if everybody decides, oh, this is the new thing, and therefore all interfaces must be 32-bit going forwards, I have no complaint about that. It's not going to do any harm. It's not going to get you anything over capture at 24-bit. The point is, in doing further work to things in the digital domain, that's when stuff like double precision comes in handy, because you can go all day long and it won't matter. But On capture or as a output format, 24-bit linear exceeds what you would need. You do not need more than that for the single input or the single output stage. Only when you start repeatedly doing more stuff does it start to matter. And for example, to carry that a little bit further, if you had a 32-bit floating point interface and then you were offered a 64-bit, it's a complete waste of time. Complete waste of time. Will not help at all. And this is me who dithers to floating point. So if that tells you anything. This is like the one case in which when people talk about dynamic range and say, oh, this is encoding below the thermal noise of the resistors into the interface, that's the only time when that actually matters. When you're processing, it starts mattering a lot quicker than that. But on capture, coming from the interface, 24-bit is beyond anything that you would benefit from there being more. And anyway, the 32-bit floating point interface is by default the loudest 6 dB of that audio waveform wherever it is, no matter what gain level you have in the 32-bit interface. The loudest 6 dB is like barely 24-bit. No matter how you have it gain staged, that is what it's going to be. So you're not that far away from 24-bit anyway, no matter what gain level it is. Okay, no more coffee for today. That was enough. That said, it's delicious coffee. I've been getting this coffee from the supermarket. For a while there, I was going to a co-op. There's a co-op in the town where that supermarket is, so I should check that out and see what they've got as far as fancy coffee is concerned. Because I'm in town, and otherwise I have to go to an entirely different town to get fancy coffee. But I've been getting this supermarket brand that is basically just fine, and it's quite nice. So let's see. Let's do some of this the way it needs to be done. We're going to build one more instance of it because we did it and it was fine, and I look forward to adding this to the collection. This is the new Cersley. There's a bunch of things. Oh, Crappy Blonde, like I said, I have so much backlog for releasable plugins at this point. There's a whole bunch of stuff that I can just straight up put out and is all ready and fine. Let's drag that over to here. So it's all very well to keep wanting to do more, and I'm very happy to have the Cersley 3. Did you miss that part, Fotis? Did you literally miss that? I don't think I saved the test part for it, but let me quickly demo what I did. I think it'll come across even in mono, believe it or not, because this mic is a mono mic, and you can still hear what it did. Effect stack. So there's Cersley 2. There's Cersley 3. You can see they are set up to the same thing, but Cersley 3 has some less stuff. I stripped some of that stuff out, and then I added Nonlin, because Cersley is all about narrow filters of exactly the kind, and they're biquad filters, so I wasn't able to do this before. Listen to this. We're gonna select an area. So we know what this track is, right? This is Discord Welcome Home. Cersley 2. Wide-nated. Now, Cersley 3. back to 2. Here it is. And it's kind of squished. There's a little extra distortion in it. And we can push the nonlin. You can hear it kind of rip. So the new control is nonlin. Here's what that does with everything else left the same. Without it, this is the previous one. There's a little extra distortion and stuff in there. This one has that taken out. So it's a little more dynamic. But then as we add nonlin, there's a whole extra edge that comes in. And then we can go bonkers. And that's what we did this morning. So yeah, Cersley 3. Cersley 3 is more capable of throwing peak energy, which I will find useful for my stuff going forward. I've been learning a lot since the days of doing this for the first time. And it has nonlin on every band pass inside it. And it's made up of all these little band passes to create that effect. They are tunable using the Q control. And nonlin works really well for band passes. So what it's doing is making all of the little resonances that pop out. You can take it to about nonlin of 1/2, 0.5, and it just takes on a whole extra level of sonority, energy, and resonance. And it's no longer clipping the peak excesses that it has, so it's throwing more energy out, which is why the level control is handy. You can pad it. And then when you throw the nonlin in there, we start getting that texture and tone into all of those band passes. And yeah, back to our ominous number. We can even tighten that up, cut the level right down. So we can make those bands more, a little grungier. Oh, and you can use the Q control. Having done that, you can really hear what it does. These are boosts. And you can hear it start to grunge up. So the way that works is Cersley is all based on boosts, but the center and space controls let you enhance the amount of extra mojo that it has and also enhance the amount of mid-side boost it'll do. So what you do is you leave the center alone if you want just strictly only widening. And you push the center if you want widening and also emphasizing the center. And the more you push it, the more of the effect you get. But also the more distorted it can get. So you might have to pull the level way back like this. And here we can hear a little clearer what the weird effect is. And we can make them wider bands. And then when we switch over to adding Nonlin to this incredibly exaggerated effect, it can sound a lot more vivid than this. Or we can make it just distort. And that's an intensely grungy, exaggerated sound. And then we can make it just be all widening. And if we do that, we have nothing but wide. So actually, cranking space all the way up is actually taking center all the way down. And it can do this better now, because formerly, if you tried doing that with the original Cersley, what you'd get would be kind of like this. Let's take the level back down. We'll match the settings. 87, 1.0, and 0.812 or thereabouts, with the Q of wide as possible. So if we do this, it's intensely distorted. And that's the same setting as this, but it's actually, this new one is wider. Because this one's distorting the wideness. And that's not what we want. And then now that we have this new one, which is not distorting the wideness, here's where we can add Nonlin. Listen to this. It'll just push. So maximum wideness. Or you can balance it to still be as wide as possible. Or we can act relatively normal and just pick something that's closer to what the real hardware would do. And just kind of hyper wide it. So that's what we did this morning. And what I'm thinking about now is at least starting with a like you've got Cersley 3, so what if we had K Cathedrals 3? Because you know the thing about K Cathedral is that both of the versions of it are now fixed. Working on Consolidated or being around, well, I put in some work as well on there. I tend to do the metadata type stuff on Consolidated because I've built all the plugins already, and so I don't have to do the plugin consolidator part. But being around for that, somebody who was running into a problem with K Cathedral found the problem, and it was an undeclared variable. It was declared, but it was not initialized, and there were some circumstances where the variable that I used, if it started off with a crazy enough value, it could blow the thing up. And that was happening on this little laptop whose screen you're seeing. And it was happening in other circumstances until we found out what was causing it. And that had been the case for both of the versions, because it was the case for K Cathedral, where I believe I first did the VLF delay. And then it was also the case for K Cathedral 2, because I built K Cathedral 2 by extending off of K Cathedral 1, which had that bug, but I hadn't found it then. And so I copied it over and went, well, I don't know what's wrong, because this has got the same stuff as the original one, and so therefore it should be fine. And well, that was indeed having the same stuff, but it included the same uninitialized variable. That's the stuff that can sometimes come and get you. So what I'm wondering is whether we can jump into attempting a K Cathedral 3 with yet another type of tone. And we could do that the same way that we got into Cersley, by first duplicating the thing and then doing modifications on it. Because as is my wont, I can do a new version of K Cathedral simply by doing a new version of the data in here. 874BU. So this is a fairly recent version of that. I may be able to hear some of these off of the monitor speakers. Verbs trimmed, precocity trimmed, precocity greatest hits. So here's the ones that I'm going to want to refer to. And here they are. So we start with very, very tiny ones and continue on from there. We probably don't have to worry about, and I may or may not be wanting to do the early reflection stuff in here, because I'm not sure how much that honestly brings. But here's all the options I've got, and if I go to the bottom, I may or may not be able to find. See, here are some giant halls and things. I had 874B-U. Not worked on that yet. File size larger than 25, 297. So this is the one that I'm using in K Cathedral 2. We settled on that. So let's see. So CU is chamber, and that one does not actually fit within some of my more recent best ofs. The work that I've been doing with these is all about trying to further get better. Like I could swap what's in here out for instance, this one, 860 SLLU, and it will have a different sound that may very well be better. Let's see if I have this set on. Yes, I've got this set on the monitor. So we can use the speakers built into this monitor to get a sense of what each of these reverb sounds like, because you don't always need the widest possible range to get a sense of that stuff. These are going to be simple one driver speakers built into a Dell monitor. They have no bass, they have no extended treble, but they'll still give me a rough idea of what some of these spaces would sound like. And as such, here's another option. And another. These are all big, empty rooms. And then we've also got tiny ones. Now, we're not going to use that for K-Cathedral, obviously. But we might use some of these. So I guess that's going to be the next question. After we begin by setting up the new potential K-Cathedral 3, which I can then use. Aaron, I don't know that. And K-Cathedral 3 will have discontinuity controls built into it. I mean, if you're talking about synthesizing a low-frequency tone or something, it is, in fact, orbit kick you're going to want. Jonathan is absolutely correct. So let's wade through this stuff a little bit more. I know it's going to be a stereo plugin, so we're going to use this option. That's my template for doing a stereo plugin rather than something else. And we're going to do yet another K-Cathedral, this one being K-Cathedral 3. So it's going to become time to wade through this stuff and copy it all over as needed. Oh yeah, download it again. That's literally what I fixed. That is literally what I know. People don't know it until I tell you. And both of the K-Cathedrals, yes. If you download the collections, and you cannot re-download it from the release page. Or maybe you can. I'm trying to remember whether, in fact, probably not. I'm trying to remember whether I went in. I think I may have, in fact, gone in and changed what exists on the plugin download page because it was enough of a bug. But normally under those circumstances, what you do is you download the big collection of all the plugins, and those are the ones with the most recent versions of everything. Because in a lot of cases, the ones on the plugin release page are intentionally left the way they were when they came out. Just in case anybody runs into a problem that depends upon them having exactly the first one that they ever got. In this case, I think I went and updated them. But yeah, re-download both of those and they should be fine. This is certainly my hope. Because somebody found the problem and we fixed it. It got fixed for Airwindows Consolidated first before anything else because that's the one where it can most quickly build a new build on new code. All this other stuff I have to do it by hand and it takes a day. So KCT for Cathedral, I to J, that becomes, so it started as KCTH for Cathedral. Then Cathedral 2 is I, and Cathedral 3 is J, and this is how I do my ID numbers, or letters, or whatever you want to call them. Whatever they are. This is going to be exciting. We'll get to explore a bunch of weird crashing noises by listening to all of these things on the Dell monitor speakers. Because again, that's going to be about as good as telling which things have more depth or not. You don't need full range for telling reverb depth. You would be just as well doing like oratones. Fair enough. Bingo. That should be the fix. So let's see what we must do here. Wetness is going to be one of the controls, but then I'm going to have discontinuity built into this as well. So that ought to do it. Bada boom. And we'll get to that. But firstly, let's replicate what already was there. Before going in and changing everything. So, boop. Here's all of our stuff, and boy, is it all a bunch of stuff. Right down to the FPDs, and just after private. So if I use this, it should simply work, because we're just duplicating what already existed before on a working plugin. Yeah, OrbitKick is not going to really make notes in the sense of that you'd be able to tune it and make a note, but as far as being able to, make a kick emphasis, or any kind of triggered additional synthesized low sound, OrbitKick probably beats the heck out of the waves thing. It's not bad. It's pretty good at what it does. So I feel like I could have left some of those controls in, but I really want to see the output of this. So I'm kind of skipping ahead in a sense. I should also check onto the plates that I'm working on. Those plates might have the same issues, and that would be worth. They haven't come out yet, but boy do I need to check. So I'll do that in a minute. I will get this to build and then I will go and check. Only that. Here's where this goes. And then all I got to do is take literally all of this and run with it and go from here on down. And I will have to change the names of the parameters. Hey, Focomas. So we start from there. This does have the bug fixes. And we go from here. There we go. But one little change. We are now using letters instead of spelled out numbers for these controls. And that's the only place where that showed up. So in theory, this will build and compile and be a working thing. But it doesn't ever compile the first time. With this particular template of stuff, it needs to go through and compile all the things before it can use the stuff that it just compiled, like in public utility and AU public, to build the actual plugin, which it will do now. There we go. And we can close out of there. We can close Cathedral 2. And let's move these up while we're at it, because that is just as valid a thing to be interested in pursuing. I think this even has some of my discontinuity stuff. Yeah, the thing that I'm working on in K-Cathedral 3 is I want to throw more all passes in, because that might, doing even a small amount of that, stepped a little bit way towards non-ringing. I feel I can go farther than that. And it'll still depend upon the algorithm. It'll still depend upon a lot of things, but I feel like I can go farther. That is something to explore today. But before I do that, let's have a little peek into here and see if I recognize anything like a VLF control. Here's our effect. I don't think we have any early reflections in a plate. Doesn't look like we have subtight. We don't seem to have VLF pre-delay either, which we kind of should, though. So yeah, we need this, but if we did have it, would it have had, and it does. So that is actually updating the part that needs to be updated. That is the parameter that was not there on K-Cathedral and K-Cathedral 2 and had to be added. And somebody found it, and then I added it very quickly as soon as I was aware. And let's just double check that it exists in K-Plate 140. Which may, and it does. Which may also, see, it's not using these. This is still being done. This is underway. So here's the whole VLF stuff. And that's based on subtype. It could also be based on Kalman, for what that's worth. That'd be an interesting way of breaking stuff up. No question about that. That had not actually occurred to me before, but you could do it. You could do it. That would turn the VLF stuff into a stone fire with the delay on the stone part, and that's a weird idea. Imagine that. Just for fun, here's what I've got currently for those plates. Let's load up some drums. They're not necessarily done, so these might crash, but I'm pretty sure I have them in here. And firstly, K-Cathedral. So we need to put this in, because that's not done. Nor is the, this works differently for VSTs and AUs, but it needs to be set up for the AU, and it's not yet. So that's going to need to happen. But outside of that, I think I have it set up in the plates. I'm not entirely sure. Let's find out. Let's do the 140. No, it's not. But there's the 140. I think damping can do the job of low cut, though. So the idea here is to let it be full sustain if needed, but then as you reduce damping, it is tightening the behavior of that plate. as if there is something closer to the plate. Here's our full volume. So if we're reusing it on a sound that was actually a lot drier than that, like you'd normally use, you could have your full damping. Let's see if low cut's doing anything at the moment. I'm not observing a big difference there. And indeed, let's see what happens when we just crank the input pad up. Oh, it did not like that one bit. Oh my god. Okay, well let's try that again. We're not going to put this out just yet. Hee. It blew up. It died. So this K-Plate 140 is not ready to release yet because it exploded. Glad I wasn't running that through to the stream output. Probably didn't hurt you too bad because my volume levels are not so high that it would have blown up the stream. Without doing that, let us play with it a little bit more. I'm pretty sure if I don't hit play and I do this, oh no, it came right back to 0 input pad. I'm not really quite sure what I've got going on with this. I'm going to have to look into that because that seems weird. But maybe input pad centers around 0.5. I think that might be the case. Let's find out. So do we have feedback if we do this? Nope. So what happens is if we're going into this hot, we have the damping plate so close to the plate that it's just kind of like distorting all to hell. And that's interesting. So most of this damping control is not useful with this guitar. Maybe this is more sensitive to input volume than I thought. Because see, you can make it really, really crunch up in a way that is very, very aggressive. What happens if we have a voice? We'll scrunch the voice up. Yeah, that's not good. So that range of suppression is clearly way too much and needs some more adjusting because it sounds insanely distorted.
Surely it's a little bit unfair.
That's less damped.
Surely it's a little bit unfair. Surely it's a little bit unfair.
So I'm wondering,
Surely it's a little bit unfair.
since we can do this,
Surely it's a little bit unfair.
that's stepping on the low frequencies of it really hard, but far too hard. So I'm going to take a minute and actually look at what the code of this is as long as I'm looking at it. We've got the cathedral ready to get experimented with, and I will indeed do that, but we are also looking at Cape Plate because I left it in a state of not actually useful, clearly. But we picked the appropriate, like, let's see, if I go back over to here, so PF, so SLLF, so what I've done, 254 SLLF. So this is the algorithm that I'm using for this particular plate. Normally it sounds like this. And F stands for front, meaning that there are more delay outputs early and less of them late. The density is to the front. And these basically seem to be winning over all the plate algorithms. The front algorithms are... No, there's one that is actually doing it. And this is what I've got for a native reverb sound that's meant to sound like a EMT 140. We've got also much bigger ones that we're not currently using. And here's a huge, huge one, just giant and cavernous. And these are all different options I can use for this stuff. Halls, back, which is another variation on hall. If we were to use that in roughly the same size, we'd have something like this. With the delay density more towards the end of the reverb tail rather than the front of it. And my idea is to find, there's a number of ideas I have going on. One of them is to find a suitable replacement for K Cathedral to make K Cathedral 3. I've already got the plates sorted out, I just need to make them work properly. But here's some of my options. And L stands for loud. I even have my cheat sheet on this, so let's have a look. These are my initial encodings. The colors and stuff are the colors associated with these. And then on the back, there's further notes. Oh, hang on a second. I got somebody coming. Okay, fair enough.
You just flip it right over.
Okay.
Right, and that goes
Good enough?
there. Yep, I can take care of the rest.
I think that's open.
Thank you.
All right, well, thank you. I'm back. If it ain't one thing, it's another. I was talking about this before I was rudely interrupted and figuring out what I was doing with these things. Okay, this is going to go back here. So what I said was, the back of this says, find the ones with very high max RMS reading and add L's to the name for each side that is 9x or louder. This has to do with the sonority I'm able to produce, and the K Cathedral that I'm using is quite good at that. And then there is a gray tag for when the final guitar decay tail has no sputtering or dropouts on the RMS meter. So some of these things are more suited to future use than others, and a lot of these are either very good in one aspect or very good in another. And 254 SLLF, this one particular, here we go. So this has all of the resonant and sonorous factors of all of the reverbs coming across exceptionally well, and also has an unusually smooth reverb tail. And that's what we're working with, but it's not behaving itself perfectly because we've got some stuff going on here. And again, see, I'm not sure P is 29 and U is 11. Okay, I do know what that means. This has to do with the way that I'm fitting all-pass filters in here. This is not entirely made up of comb filters, as some of the early ones were. They tended to be on the metallic side. And when I say P is 29 and U is 11, what that means is I've replaced U with an all-pass filter, and that's delay U. And then the next smallest one is delay P, and so I've got that set up with an all-pass filter as well. That's what that's doing. And we've got all of this stuff here. I do not think I don't think it's actually, I won't want to include discontinuity on the plates because the plates are not actually a physical space. I will want to include the delay though. Like all of this stuff is commented out now. So we've got these, it's all spelled out in various ways. Regen. See, I think this is what's causing that effect, SB. That's going to be short bus. I've got an instance of short bus running in here. So here's what we've got. We've got a all-pass slot that is being very subtly pitch drifted. And then I know that I'm applying, see here, this is what short bus is doing. Here's my outputs, here's the cycle end, so on and so forth. So this part is working, the feedback and so on and so forth. Times SBER. So this is doing a thing that is presumably calculated to let's see. Well, I have not so long ago put out a current version of shortbus for the modern world. Let's see where I took it when I had it. And in fact, see, here's that guitar that was so nasty. Okay, element of P, there we go. So you got a negative or positive of this. That's interesting. I would have thought it would do more. What the hell did this do when it was the thing? Let's see if this visibly changes the... It totally does. Okay, so there's shortbus. The way it exists is not the most aggressive way that you could have. But all the same, it's having a pretty powerful effect that you can plainly see. So one thing we could do is fool with the sine wave and see what it does on that. Here's one. Yep. Once it finally kicks in, it starts doing this. And this is the kind of stuff that was freaking out the reverb tail on a bunch of things like that. So this is the basic process that we're applying to make this happen. It's just sort of tricky and subtle. Let's see what happens when we do the opposite. That was +1, but it goes to -1, which seems to not be doing a damn thing. So we'll undo that and try it again. Yeah, shouldn't you be doing something? Apparently not. Apparently positive shortbus does something, but negative does not. And the way it is implemented is like very similar to what we see here. That's exactly the same algorithm. So it gets applied by like this, and this is exactly the same routine. And SB scale is how we apply it, and then it needs to be taken down in size by this, or all hell will break loose. So that's interesting. Well, it has a much bigger effect on the plate, so let's see what we can do. This all seems legit, that this is in the feedback loop. It's applying to every path of the feedback loop. And here's where we hear what it starts doing to stuff when it starts doing stuff. And then this whole section is delaying lows. It's using subtype to do that. It's delaying the lows. Seems to be a pretty fixed frequency section. I think this is a bit hard-coded. I think this is doing a particular sub-delay that's calculated in to do exactly this. So I should be able to just turn it on and both of these things will then work, which is fine with me. I could very well have pre-delay involved here, but a lot of this stuff is not actually connected. It's going to be redesigned. It's going to be recalculated. As such, let's go in and remove all the bits that I know are not getting used right now. Like damping is 3 and 4 are not getting used. So right now those don't do anything. So damping goes up to 5. Do I want to keep that? I don't think I necessarily do. Let's put that back. Ah, and see there now, max value of 1. We're not using this. And there's no reason for that max value to be 0.5. So now these are all working along the same format as all of my other stuff. Fine. So where are we getting some of that information? Param2 is supposed to be able to go up to, what, 5? But it's not. This is going to be a fussy little adjustment, isn't it? That's definitely going to be a fussy little adjustment, isn't it? And then that makes no sense if this was such a large number. So if it's 1, that's returning to the realms of sanity where it was not before. So we're slowly getting there. We're getting to why this was not doing what it was supposed to do. Regen should be giving me less regen rather than way too much at this stage, to the point where I would need to scale it up to make it work again. That's probably good enough to see what we get when we build it. And I know that I was discovering the bad things through using Rise Dirt Guitar. So let's see if this explodes or actually works this time around. Okay, plate 140 once more. These do nothing. And damping can start at full damped, and we'll see what good that does. Wow, okay, that blew up. Regen is still capable of exploding. That's interesting. Let's start this over again. From the point of quitting the entire program and regaining. So I know that if I do this, it screams and dies. How close can we get to that? Would help if I had it make a noise. Hey, Jess. Can we drive it into exploding? Damping of 1 is clearly capable of blowing the heck up. I can't say as I'm happy with the sound of that. I'm not. So 2 things I notice. One of them is that if I set it to 1, it explodes. So that happened. I think that's going to be regen. The other part is that if the SB scale is the wrong thing, that also explodes, but differently. So now what I'm wondering, can I make it scale this differently so that I have a working regen thing while SB scale can temporarily be shut off, which I can do by commenting this bit out. Also, I want to find out if that causes it to blow up. Like, can I make it not blow up? We'll turn down the audio for this one, because now we are attempting to replicate the explodey or not. Was it literally regen doing that, or was it some interaction with the other thing? And there's one way to find out. Into the breach. Let's see whether it blows up. Turn you down even more. Oh. Huh. That's special. I can't make it explode now. That's interesting. Yeah, if I take that away, damping blows the heck up, but I'm not even getting infinite sustain, not even close. Interesting. Interesting. That means it's the short bus content that's capable of making it go into exploding. That's very interesting. So what else might we be able to do to test this and start fooling with it, making it so that it'll sustain for longer, because our regeneration is not actually giving us what I thought it was. Here's feedback EL plus the short bus factor. Here's feedback all of this feedback being calculated this way, that's how we get this as sustained or potentially not. And this is how we get it to explode or not. Here's where things get interesting. Could we maybe reformulate all of this in such a way that it's another... We're doing a lot of signs here, but what am I going to do? Oh, and we're also softening all of these with a simple averaging, which is probably fine. This calculation is being done after we do all the other calculations. What happens if we throw a discontinuity onto all of these outputs? Because that gives the feedback. See where it says feedback plus feed blur times 0.5, that is making an average, that's making temp be an average. Then feed blur equals feedback ER after we've already made the average. And then feedback ER equals temp. This is where we could do feedback ER equals sine temp, which for small values is not going to do anything. But for large values, nothing can go above 1, meaning that should be able to control the explodey overdrive. So let's see what happens when we do this. We'll sort of copy paste this in here and then continue. This is a lot of math functions to do, but it might be worth it. And then I'll tell you what we're going to do after that is crank up our amount of feedback until we can make it be far too much. That's going to live over here somewhere. Here we go. There it is. So if instead of regen being param2 times this plus this, we just had way more on tap. So regen can go down to like 0, meaning there would be no feedback whatsoever, or it can crank up to presumably much too much. And then this is doing its thing. Presumably that's compensating for the fact that we have so many of these parts feeding back. Let's see what this did. Did we just get a thing where we can now make it sort of roar and scream and feedback but without exploding? Or what did we actually make? I've got the volume turned down to 1, so this is probably safe. And let's see what we can make this crazy thing do. This may be a mistake, but we'll start with damping of totally nothing. This is like no regeneration. I wasn't expecting it to be this effective. That's a lot of output, but that's not doing the thing. Yeah, that's not even close to regeneration. We have made a mistake of some kind. That's okay. It's getting on towards 3. Soon enough, it's going to be dinner time. This is a day for derping with this, I think. I feel like derping with this harder. And so we're going to see what we get. And what must we do? That's clearly making stuff be a lot smaller. So regen being 0 to param 2 should be making it larger. And then here is where we're scaling it way, way, way back down again. So where's this even getting applied? Feedback times regen. Here is this with it. Here's the output of it, and here is it getting added back. The overall output of our stuff is pretty high. And here's our temp output, and this is what is restricting the maximum feedback output. So I think what was happening is this would become a very large number, and then it was being scaled down by the input level. But it was going around being an extremely large number, for starters. Large numbers, you say? We can do that. Now regen is huge. Let's see what happens when we have this sine function going on the feedback paths of all of our regens. And we've got the output of the Lavery to really, 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 really quiet. It's set at literally 0, 1. So it can't really get much quieter than that. With this, we should be able to make it scream, feedback, and explode. And let's see what happens when we do that, because we were very far away from getting it to do anything. And we don't have the short bus in effect anymore. We just keep simplifying this down until we can get something to happen. Here's this at 0. What do we got to do to make it blow up? Or is this even doing what I expect? Well, more. Come on. Come on. You can do it. Come on. But it can't, can it? That's all we're getting. All we get when we do this is this as the feedback. That's not decay at all. That's not reverb sound at all. So some of this stuff needs to get dialed right back because it's taking us in the wrong direction. So let's undo past all of this. We'll undo that too. And then I believe this is going to start because that was also a problem. That's part of what made it not work at all anymore. And what else have we got going on here? I think we go back up here to see the next parts of the undos. Such as this. but I'd like to take it from here. So this had been a larger number. Damping used to go up to like 6 or something. I think I might have had it at 5. Multiplication is commutative. That should restore what it thought it was doing before. The only question is, firstly, have I left this cut out? No, I have not. So our volume is still right down. Let's see if we put it back to having all of the amplitude going on and the ability to sustain, which was actually kind of working. But also the platey tone I had going on that did have sustain, just not in a useful way. Our level is still super quiet. Our damping should be very small. Ooh, hey. Okay, so that exploded instantly on site. Far out. What if there's almost no input? Oh wow, we can make it go whoosh. Oh, until it goes splat. Interesting. Interesting. So what evilness do we have here? Let's put on the drums. The drums blew up less quickly than this. I have no special objection to spending the day derping around with broken things. That is definitely total feedback. And I am showing an ability to make it be able to cut out. Input pad is real sensitive here. We're able to drive this into exploding very quickly. Strangely 80s. So this is clearly not going to work for real sounds, but it's showing me a little more about what's happening here. As soon as our damping intensity goes up, with the very delicate range of adjustment on it, input pad is able to drive it into complete madness. If we cut the input back, we have a sustain that may or may not be in the zone of something that could be useful. Turn it back up for this. We can make it do this. That is a long sustain. If we make it start feeding back on itself, it'll start clipping. Start doing weird stuff. Like this. See, it's going higher in pitch, it's getting strange. Taking damping back in this direction causes it to kick in harder. And we're able to overdrive the verb as well. So more damping, that short bus stuff is still active. It's doing a delicate balance where it's making an interesting and useful sound, but it's really a bear to work with. And then the input is, you begin immediately overdriving it with the input real easy. It's like incredibly sensitive to that. And the short bus calculation is too delicate. So what's happening out of this, before we bring anything else in, SB scale is very definitely doing something, and it's being applied inversely. So it's 1 minus get parameter, so it's very close to 1 times 6 times negative blah, 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 all this other stuff. Short bus was a factor of let's take a minute and check out what actual short bus, because this is now a negative setting. So if we take all this and make it a full range effect, what do we start getting? If it is a negative setting, it seemingly does diddly. It ain't doing nothing. If it is a positive setting, we're going to see some action. I don't know what's going on with that. That's weird. We start getting this intense effect. So I'm basically trying to work out what was up with this one. Ooh, at a small setting, we're not seeing as much of an effect. Let's try more. Well, it's trying to do something. Maybe it doesn't want to be working on a simple sine. Maybe it wants to be working on more complicated waveforms. Just a minute. Oh, I'm sorry. I've been showing nothing but this. Well, no matter. Everything's got to be something. Let me see what I can do with... Now that we're looking at that, let's look at this. I wanted to find out what short bus did. It is a available plugin, therefore it lives here. Okay. There we go. Sine waves are not imbalanced. Short bus will try to find second harmonic or imbalances in the waveform and take those away. So, reverse short bus will fight even harmonics and try to take those away. And that's why we're trying to use it here. And that's why we're not seeing any effect out of these sine waves, because sine waves are perfectly balanced and it can't do anything. Or if it finds just tiny amounts of it, it forces an extremely powerful effect on that. And that's why the sine wave stuff is useless here. Let's close that without saving. Let's have a look at a voice is going to be a sound that does in fact that's not a symmetrical waveform at all. So here, if we do maximum short bus added, adding it is finding imbalances or enhancing imbalances. But what of the reverse short bus that we were talking about? Because this might simply be that might be it trying to find and remove. Yeah, there you see. See, so it was finding this moderately symmetrical waveform and making it more asymmetrical. But now, what we were doing in plate was negative short bus, which does more like this. That is fighting the other direction. I should be able to run that on the fly like this. Can't really hear much of a difference, but then second harmonic is hard to tell. No, this is a Wild West plugin. Don't worry about that. If you find it a little bit daunting, not a concern, because this is the sort of thing that could cause you a problem. Let's see what we've got here. Fair. So maximum positive short bus did this. So let's see, trying to find imbalance, and it's trying to augment that. So people are using righteous for this, and it does say plain and simple second harmonic can be hard to hear. Also, we might not be applying enough of it for it to be obvious. If we undo that, we get to this. And then the negative short bus that I believe is what went into K plate. Full crank. Let's see what we get. It changed something. I think that might just be trying to fight asymmetry and compel stuff to be closer to the... And undo that. Let's see if the waveform changes location or position in any way. A little hard to tell. Well, here's a place where it does. So let's look at that waveform and see whether any of the parts move around when we apply it at full negative. Not as much as I would have thought. Maybe I can get more out of it here. Here's the dirt guitar. This is louder. So can I make, this is louder, so can I make it do more if it's louder? Well, it peaks at about minus 0.4, no, minus 0.2. Peaks a little louder here. So yeah, this is not as extreme of an effect as I thought it was going to be. It certainly doesn't apply to everything. Let's apply it to something that I know is very bassy. This is bassy and it goes all the way up to full crank. If I was to apply short bus to this track, it's doing something because we're getting peaks that are substantially larger than we would otherwise get. So the peaks we show here are getting up to like 6 dB. And if we apply this and then look at what it does to the waveform, it's going to make it be one-sided. And that is short bus chasing second harmonic and adding more and more and more of it until it's really done a number on the waveform, while a lot of it is still centered, but we're doing all this second harmonic adding. So what we were doing, and let's see what it does here, now that we've got it doing obvious things. If we do full negative, like we're doing small amounts of in this reverb algorithm, it's fighting that second harmonic and constantly trying to make stuff be more centered, although it's not the most obvious of effects, is it? Should take a while for it to kick in. I remember when I was using it on a bass, what was happening was I could make it do the sort of using righteous for sonic effects when you added it. But when I subtracted it, it tended to make the electric basses sound more like sines. And that is, I think, what it was doing there. So we're looking at it here in a reverb algorithm where it's very tricky. So let's see. If we could only use, if we have more of it happening as you move all the way to the left. That's what this does. It's 1 minus this parameter. So if I crank to regen all the way over, part of it breaks up, screams, explodes, and dies. And that is because my numbers are not right here. But part of it would be removing SB scale. 1 minus 1 means SB scale would go to 0 at that setting. We're not able to do that because it is upset and not right. But what we're doing is we're taking that factor and multiplying it by an awful lot, but then we're also multiplying it by negative because we're using a negative value to make stuff be more even, and then we're making it tiny again. So what do we get if we don't multiply that by 6, but we do multiply the regen by 6? Because we had this is all very tricky to work out, clearly, but we had the regen being able to really kick it in. I'm turning the volume down in case it explodes, because it might explode. And we're going to go into the guitar that distorted so nastily the last time we tried it. We're going to fire it up and see what kind of behavior it has now that... Oh no, that's the wrong one. That's a recently used one, but that's not what I wanted. So we had it so at low damping and low input pad, it behaved. The feedback is kicking in real fast. So what things are happening here? Well, one thing is that we are taking that regen and multiplying it by 6. So if it was supposed to be 1 instead, then unity would be around 0.16. That definitely sounds a little bit like the regen is sustaining, but the amount of this short bus processing is so intense that it's just crushing it. Yeah, there we are. We have some sustain. That is a sustain, but short bus is so intense on that. And if they're linked, and I turned this up to 1, or anything where it's like, I can't turn this up to 1, because then damping would be far too high. But I can't let the input pad through without feeding too much in. So I think what the next thing is to do is to take this multiply by 6 out as well. If I do that, I might be able to get it to where the regen is doing sensible things. That said, this is the same condition under which I was able to make the short bus part cause it to explode. So we're going to leave the volume really low for this. And we're going to build again, which I just did. And we're going to throw that dirt guitar on, which is demonstrating all of the ugliness of excessive short bus. Because what we got to do is leave regen going, but scale down short bus enormously. And firstly, let's see if it even works at all without exploding. Yep. Okay. So we're able to have a sustain but this might be the context where it can explode. I'm not sure if that's the case. Like if I hit it with full crank. No, it seems to be able to recover from that. I feel like this was the context under which it was exploding. But right now, it's kind of hanging on. But what's really happening among that it is much too loud, because it's much too loud. Among the things that are happening or it's no longer blowing up in feedback, and that's cool. We should be able to have 0 short bus under this circumstance. What that would mean is that as I start increasing it, now it's far too much short bus. Ooh, there we go. We got it. We got explode. We got explodey. Good thing it was on 1. Oh, and I am still not showing you the screen. Let's do that, shall we? It's because I'm working in these 2 places, and it's because I've had a lot going on recently. I think it's probably that loud knock on the door. It was the postman with a registered letter for... There's a bunch of stuff that's going on crazy in my life right now, and I'm not going to get into it. Only to say that being able to focus is going to be a struggle for me at the moment. So, what can we do to scale this down even further? We could scale it like this. It makes me wonder, why do I need to dial this back that much? What's going on with that? Like feedback ER plus equals 2 times feedback times itself. So that's a factor. That's how we're doing short bus in the first place. And that's what's causing this result. And that's probably why it's responding so strongly, is because at the point that we get to actual feedback, that is a very delicate balance. So this is an interesting scenario. So here is some things that are happening. This is the feedback ER times SBER. That's how much we're putting in. SBER is feeding back upon itself. It's being added to by feedback ER in the first place, minus the sign, so it's only the amount that's being added, and SB scale is the thing that we're changing. SB scale is what has to be so ridiculously tiny. So it's going to blow up really hard with larger amounts. And SBR equals sign SBR times this times this. That is a dialing it back factor. This line of code with the times 64 on the end of it is what is dialing it back in size. And these are shiftings of bits, so it's keeping it real accurate. But it's basically just a sanity check. It's stopping the value from going crazy. But if the value is near 0, it's going to do next to nothing. That is also how I could make it become smaller. Or stay smaller. So something that I can do to start fooling with it is dial all of these back much, much faster. This is going to force them, I think it should do that. This is going to force them to become real small real quick. We're like attenuating them like mad. Let's see what happens when we apply the same thing and all the same stuff, but that's the only change we've made. If we do that, is it going to be able to hang on to the reverb behavior more easily, or is it going to be the same, or is it going to be something else horrible happening? Well, we can make it, this equates to 0. But then when we start applying it, okay, that is making damping apply. But we're taking the short bus calculation down so repetitively and so quick. And we definitely need to do the whole gain if this is off. It's supposed to be fairly comparable volume, rather than not even slightly comparable volume. Oh, Crappy Blonde, thank you, that's very sweet. So this amount of damping is not bad. That is not a bad amount of damping. I feel like maybe I could push it farther. Let's zoom back to here, or if I can find it, there it is. So is this actually appropriate? What if this was to 5? Or does that actually need to be 2.4? Well, we'll find out soon enough. It's a very small change. Excuse me. So if I shouldn't have made that change, this is going to blow up in feedback now, or soon. It did not blow up in feedback, but it's close enough. This might be thought of as excessive. That said, I think I can live with that as undamped. Giant plate, or at least if we can get it to sound like a plate, it'll be a giant plate. Also, can we make it feedback? No. about the right amount of damping for regen. As long as that part is working okay, I'm fairly happy with how that is. I do want to scale it differently. And I'll show you how that's done. Oh, this is all a little sketchy and weird, but that's fine. I shouldn't have to do these two calculations like this, but go figure. It is what it is. So firstly, let's throw extra parentheses in. You always need extra parentheses for everything, which is not really true, but what the hey. So now what we've done is regen follows this rule. There's a power factor which normally would make it push towards the small end of the scale aggressively. If I did a power factor and regen was working the way that it was working, all that would happen is that it would force it to be no regeneration as quickly as possible. However, we've done that power factor on 1 minus get parameter param2, and then we're doing 1 minus the power factor, which means we've done the opposite thing. Now all of the variables are tending towards 1. And this will not change its ability to feedback or freak out or whatever it is. Also, this I think is a fine time to adjust some of those volume levels. Let's make it be exactly that much quieter. Exactly half as much. And if we do this, plate 240 can also have the same effect. I just gotta dial it in, and then 240 has a different thing and can be tuned in different ways. Ooh, that's special. Didn't expect that. Wow. Didn't see that coming. Not even a slightly tiny amount. Damping is not doing what I thought it would. That's rather magical. Could it be just my output level doing that? Because what we got now we're able to crank it up to huge values. And it's not supposed to be doing that. Only thing I did was, oh, hang on though. There's something else in here. SB scale is a factor in this. So let's change that last 1 to a 0. This should make this no longer be a factor. If that's what's going on here, that one change will have made it not do the thing. If it still does the thing, then more nonsense is afoot. Let's find out. More nonsense is afoot. Oh, now it's like literally feeding back. More nonsense is afoot. So I made a change. I changed 25 here to 24. Could that be the final detail that caused it to lose its mind? Because that 24 might have been a real number. Regen is very sensitive. It's very sensitive to very tiny amounts. So we're going to see whether that should have actually stayed at 24. Or indeed, it should be an even smaller number than that. Because guess what? We are on the verge of feedback. We've got spare controls we're not using. Let's dial it in using some of those. Because this is kind of silly. We're fussing with this. So regen this times 001, so 0004 plus 0024, but instead, since it's 0.16, it can be 0.024. None of this plus business. This can go away because we don't need that anymore. That should make the smallest amount work. And let's just see how close to sanity we are at this stage, having just applied those changes. And before really worrying about bringing in another control to dial it in. How close are we? It's a very sensitive little control, this. Ooh, okay, it didn't like that at all. Instant explosion. Thank goodness I don't turn this up very loud. Welcome to the explosion, the ongoing explosion of my brain and my life. Regen. So that was far too much. Let's do one further test before tinkering with it again. Because I don't know if I had it set to literally 0 on damping. If damping is literally 0, damping is literally 0 and it still can't handle it. Okay. That means this control is off. Because this produces 0 if it's fed 0 times this remains 0. That also means that this number is way too high, but it's still going to be 0. So this plus is the problem. So there's one quick way that I said I was going to try before. Namely, let's bring in another one of these parameters that I'm not currently using. Because if this parameter is 0, then we're starting out. We can have both of these be 0, and then it should not do the thing. He says with amazing optimism. Let's find out. we are turned down as far as we can go. So this is the one where if it was set to this, it blows up. And this is the one where we're supposed to be able to turn it all the way up, but probably can't. Let's see how far these can go before everything explodes, if at all. Hi. That's really weird. What's going on with you that all of these things can be 0 and it still explodes? Whose little friend is that? This is not my friend today. It's not being nice to me at all. And SB scale is supposed to be zeroed out. Alrighty. This is leading nowhere good at a staggering rate. Let's start undoing back to where we can get into something that worked even if it worked wrong. So we had that. We had that. We had that. This may have been the last working state. Let's find out. The stuff that I did to tinker with it should have been able to work, but I don't know why it didn't. But back to something that maybe was... Good night, Crappy Blonde. Wish me luck. I'm going to need it. We need to go farther back than that. Okay, we're making those things louder. I'm not sure if that matters. And I believe this is the last point where it worked, but there's no damn reason why that would be. Oh, unless all of this stuff is, maybe it's a precedence operation and it just needed way more parentheses and everything. Oh, let's find out. That would be a very good reason for everything to blow up and die if I miscalculated certain things about that. Let's see if we get back to a state where it acts a little bit more like not completely insane. Yeah. That's cutting off real fast. And this, that's what I expect from a long delay. And this is supposed to be closer to the long delay, but it's really not. So where did we go wrong? So what I tried to do here was supposed to make it act like it was the same thing, but not. And when I say that, I'm trying to express the fact that I want to put a power function on regen. But I have to put the power function on regen before it hits times 0.425. And maybe that's what happened. Because this thing has to be all scaled down to work. And if I do this, like I'm willing to bet this is going to work too. If I do this, it will cause everything to make quick decay time even faster than I want, and I want the opposite. Let's see, however, if I can do that which is supposed to be able to make it do the decay time even faster, which is the opposite direction of what I want, because I was trying to reverse that effect and doing it wrong somehow. And I believe I might have a guess as to what happened. Longest? I'm basically okay with how long that's lasting. Shortest? And then this is supposed to be way closer to the longest, but it's absolutely not because I'm using that power function in there. So what I did was put a parenthesis around this. When I did that, I was trying to subtract 1 . So here's what I'm thinking. I think I put the parentheses in the wrong places, is what I think happened. So let's have another look. This is the part that needs to be outside all the power function stuff. I can do a power function of 1 minus get param 2. If this bit goes to the outside of the power function, that means anything I do inside here is not going to affect the multiplying by 0.425. However, if I had them placed wrongly, rather than having a 0 to 1 at a different angle multiplied by 0.425, I would have had a 0 to 1, but it would have tended to make everything be larger than 0.425, scaled down to something in the vicinity of that. And that would cause the additional sustain. So in order to make this work, I would do it like this, and then all of this stuff lives inside here, and then the end result of this whole calculation gets multiplied by 0.425, meaning that the same calculation should be producing the same total result. And we'll find out very quickly, because remember, we still have to bring in that short bus calculation, which will cut down level and provide a really aggressive effect on things. So full sustain is still, it feels like it's a little longer, but to a degree where I can live with it. Minimum is supposed to be much more clamped down like this. My whole volume levels are way too high, but that's a separate problem. And then halfway should be sustaining more. And we got there. Good. Now the bit that's missing is this SB scale stuff, which I think may be active. I think I might have just added so many points to this. Like this negative 0.00000000001. That's a lot of negative. That's a lot of making it smaller. And that all lives here. And making this smaller in this way, we're making it incredibly tiny. If we put it back to 64 again, let's do this with one keystroke. That's the scale back control, where it's supposed to be restricting itself. This is allowing these numbers to get larger because only when they get large enough do they start to run into the limits of that sine function. And the limits of the sine function are what's stopping it from, like, if there was no sine function there, that would equal give me the same number back. But it's supposed to be restricting it in some way. Because this is the maximum amount of short bus influence that's supposed to be on there. And it is being added to by feedback minus sine feedback, so it affects it more as the volume gets louder, times SB scale. And times SB scale ends up having to be incredibly tiny. And that might be its own concern. I don't really know. I just know this is what it did. So if this is doing what I think it's doing, what we're going to have is the feedback part will work, but we're going to be back into that zone where it gets incredibly distorted as soon as you back off on the sustain, and it will still be too loud. Yeah. I'm already hearing the saturation. And with this, the plate is so close that it sounds incredibly messed up. Okay, so guys, it's 3:58. So what I need to do, there's a couple of things I need to do. Firstly, let me close out of this because I'm not going to be using it today. This is what I was going to use in order to find a better cathedral reverb, and we're not even close to that. That's not going to happen today, but we might be able to get something done if I'm lucky. And we're going to fire up some kind of cool thing of some kind. Maybe it's just null pointer. And we're going to put on SWB audio capture, and I'm going to run to the facilities and also get some food thawing out for my taco dinner, which is what I enjoy. I don't even know what this is going to do, but let's see what it looks like on the new meter. And somebody was asking earlier, the new meter will come out when it works and when the build system is working. And the build system will work when I've uploaded a bunch of what they call secrets to GitHub so that it can like sign things and so on. Possibly after I have made a Microsoft Azure account at like $10 a month and set up to sign stuff through them. And when Sudara has helped me deal with some of those things and making them work. And when it does that, it'll start building downloadable files on GitHub every time I make a change and upload it. But for now, we've got this. And I'll be back in a moment, I'm sure. who was not happy what I just did. I wonder if it broke anything. For something that reads so well on the meters, that's a really goofy, ugly sound. Fair enough, man. Nobody said it was a real hit record, just that it made that kind of pattern. Crappy Blonde, I don't know. Maybe you don't. My experience is pretty much that I need help to make it be able to produce downloadable files that people can have. I'm lucky to be able to make it at all myself. I'm delighted that people are enjoying that. This is one of the things that is stopping me from beginning evergreens. As much as I'm enjoying showing off like what I could eventually do with evergreens, I'm really resistant to launching that, to starting to put up videos with commentary on classic hit records measured using this meter. I'm really hesitant to start doing that before people can download the meter. And so, yeah. So, yeah, my answer to that is I don't know, maybe you don't. And this is interesting. So here's an interesting idea. If these exactly match, but this one makes it smaller to apply a sine function, and then this one makes it larger again. What if I just take one of these down by a tiny amount? Or I could make it feedback and blow up by making it be 5-1, for instance. But instead of doing that, what if I just apply a tiny amount of scale back? Now, if I put it back to 15625, that would be exactly matching again. On the other hand, now that this is not only scaling back overshoots, but it's also scaling back everything by a tiny amount. All right, good night, Crappy Blonde. I mean, I'll do it as soon as I can. There's a lot to it, and it's all way over my head. Sudara could do it, but he's not. Or rather, he did the original ones, Pample Juice, and it's waiting on, in addition to maybe having some of that stuff fixed, it is also waiting on me uploading all the relevant secrets. And me and Sudara have talked about it, so it's kind of in the right direction. There's just been a lot going on, and I'll do my best. What do we got now? I definitely need to add more all-pass filters to this. That ringiness is still showing up. So let's see. I think that helped. At least a little bit. And I can also add tiny amounts to this, like it went from 25 to 24. So if it was 245, that's splitting the difference. But more relevantly, bits of that were enough in the zone. I want to try it with a bunch of other things too, but that's fine, I will. Bits of that were enough in the zone that I can start looking into doing this kind of thing. Where we are scaling back and forth. Like I could have a whole stack of stuff in this way. Because what we want to do here is allow this to take effect. It is an inverse. Oh, my neck is hurting. Oh, too much stress, just too much stress. The good parts of it are things like Airwindows Consolidated. The bad parts of it are some of the stuff I'm not telling you about and the inevitable bashing my head against stuff like this. So, SB scale. If SB scale is 0, then we are not inflicting this nasty grunge on the tone. If SB scale is larger, which is still a very, very small amount, we are inflicting this horrible grunge on the tone. And it is inverted. So, if we just add a power factor to this, like 1 minus full crank equals no effect. Halfway means it's 0.5. 0.5 times itself is smaller than it was. So one thing we can do, since this is where our parentheses are, and on the outside of these parentheses, everything gets scaled back down again. So on the inside of these parentheses could be a power factor, just like this. And we do that by adding that. And then again, the power factor is applying to the stuff inside here. So when we have full crank, we're at minimum amount. And the larger multiplication we have here, oh, that's supposed to be a comma. The larger power factor we have on here, the more it's going to keep scaling it back. Kind of the opposite to with the regen, the larger power factor we have on that, the more it's going to sustain as we move it to the left. Whereas on this, the larger power factor we have, the less of this effect will kick in even while we move it to the left. So let's try that. That is perhaps a significant effect to take place. I would still like to scale all of this stuff better. I am unhappy with the amount of output level I'm getting. So that part's still fine. Feedback is still fine. This should let me just dial everything back without causing another problem. Let's find out if that's really true. Because yeah, this would be input sample and all of that. It's producing those things. In no way are we doing anything other than taking the output of this, so this should work. I don't really see why this wouldn't work. Famous last words. I've said that before. We're definitely in the end of day burst of madness and hacking. So if that did work, input pad can be turned up more than it had been, and damping gives me full sustain now. Yep. And even if I sustain it and distort it, which I shouldn't do, we're not getting infinite feedback. Ah. But this is doing too much. Like, some of that is right, but this effect is kicking in way too aggressively and way too fast. At no point does it actually sound good on this sound. Should be about half of what it is. So let's experiment with that then. And here's our volume level. Let's chop that in half again, because our output is so damn loud. That might help. And all the way back up top here again. So we're fussing with the balances between our feedback and all of that. Half as much if this means it goes to 0.5. Let's see where that sits. I could bring in one of the other parameters, and I feel like last time I tried that, bad things happened. There's no reason I shouldn't be able to, but I don't care. I know that this dirt guitar is able to make it a raspy mess. And so that's what I'm going to try to do, is make it a raspy mess to see what happens. Come on. Go. There we go. Ah! It's still a raspy mess. What the hell? Maybe even worse. This I don't understand. What the actual heck? Maybe if I was scaling one of those other parameters? Maybe I've done some of this backwards? I wonder whether I've done some of this backwards. What's going on here? Here's the place I was wondering about. Okay, so 15625 times 64 puts it back again. And this is how we make it be a big obvious effect. So if we work on it from the other angle, and let's see if we can like force this to be smaller when it's set to its new number. And that would be done by, see, here's SB scale. It is tiny, and changing it to do this did not help at all. So we're going to call this rebound because it's part of that sign calculation where it's making it be able to respond to small things, but then it can't expand beyond a certain size. that's what that's about. So what that would mean is using this parameter again. But if we do that, because we're rebounding by multiplying things in by 64, if we multiply them by smaller amounts, they'll rapidly go towards 0, which is what this other thing is supposed to do. So we've now got that tied to the same control, which should mean that as we make that control smaller and the horrible noise kicks in, this should also diminish its ability to do that very same horrible noise. The question is how much and how effective it will be. But if we can get it to be sort of on the curve, it'll be possible to wrestle that effect into shape. Or not. It's possible that it won't. So let's see. Here's our damping. There is our kind of ringy sound as it persists and sustains. And I hear it doing something in there. What happens if we go to 0? Well, this is getting safe enough that I could turn it up again. Full sustain. So no attenuation at all. And this is meant to be plate-like. Now we got more attenuation. Kind of a lot less. Lots of damping. Let's put it back to where it's making a sound. A little less. Maximum. I think this is almost leaning in the direction where it could be workable. I just need to do a little bit more, and I'll tell you why. Because the scaling of this down to 0 is doing too much to restrict that nasty tendency to make high frequency distorted grime out of my distorted guitar. Drums is easy. Drums, you distort it and it sounds basically the same as it did. But there's a bunch of other stuff, like I can start running sines and things into there. I can run my bass sine into there and see what it does. But before doing that, what I can do is split the difference. Now it can still go up to 64, but it can only go down to 32. So it can only go down to chopping the volume of the short bus algorithm yay much. Also, I wonder if I can take some of the zeros out of SP scale. I really wonder. It seems like excessively small, this. Let's see what we got. Zooming in towards the end of the day. Maybe on Thursday we can ride on the successful results of today, assuming it does end up being successful, and make something helpful out of all this. Like a couple of plugins. That sounds almost like a heavily damped plate should sound. Let's restrict that. Okay, it is now what's the VD2 plugin? Oh. You know, that is a very mysterious observation. I would love somebody to dig into that, like prove it. Prove it's more CPU efficient. Neat though that would be. Well, that's looking good. Let's try something else. Let's try one of the main vocals. This is also from Rise. And I should be able to make this real gritty in the reverb if this works well.
Only rightful governor of your affairs.
So very undamped.
Who's the fool who stands and dares to deny the only rightful governor of your affairs? Know him now, there's no one fairer.
Fully damped.
Show by all he'll take away. Love's a trick and life's a terror. What then do you have to see? Only rightful governor of your affairs. This amounts to downright spiteful. Who's the fool who stands and dares to deny the only rightful governor of your affairs? Know him now, there's no one fairer. Shown by all he'll take away. Love's a trick and life's a terror. What then do you have to see? Only rightful governor of your affairs. This amounts to downright spiteful. Who's the fool who stands and dares to deny?
So what's happening here is we now have a nonlinearity where you can overdrive the plate against the backing damping pad. And that's an interesting result. So we push into it harder, and we hear more of the rasp of it. And then as we go beyond, we get more of the echoey stuff going on. And if we're not actually driving it that hard, so input pad clearly has to stay. That's something we're going to continue to need. But if the damping pad isn't in place, it doesn't really care very much how hard you're pushing it. Whereas if you have damping in, we have some character going on in there. I feel like I could make it grittier when fully damped. How much grittier is a good question. But on that kind of sound, that's giving me a pointer towards how much grittier I could make it. So instead of 32 by 32, how about 48 and 16? Because it's got to rebound back to full crank, which is 64 in total at full boost. But we can push it harder than that. We'll also try it with that guitar. That guitar clearly shows when stuff gets nasty. So here's our main vocal, just as before. Here's our plug-in, just as before. It's coming into shape. There's our plate sound. And are we getting it to where it sounds like we're overdriving a plate that is completely damped down? Can we make quiet sounds, not push it as hard? I think so. So if we were doing it as a added effect with wetness at about 0.5, we've got some heavily damped plate.
Love's a trick and life's a terror. What then do you have to say? Only rightful.
And then the grit is kind of there.
This amounts to downright spiteful. Who's the fool who stands and dares to deny the only rightful governor of your affairs? Know him now, this etc. What then do you have to say? Only right.
So input pad's going to be very important, certainly.
This amounts to downright spiteful. Who's the fool who stands and dares to deny the only
And if you have it really crunched, we have a kind of crackle going on.
What then do you have to say? Only rightful governor of your affairs.
And if there are very quiet sounds, it doesn't distort like that, does it? In fact, it sounds a lot more distant this way. And the harder you push it, the more clearly it starts to sound like something's going on, with a heavy distortion on it, to reach a comparable output of the input. And of course, if it's undamped, it gets much louder. That's useful. It's like a dynamic restriction. I wonder whether that's maybe a little more than it needs. So let's try that guitar again, because I know the guitar shows it if there is too much. Because it's really clear that something is getting raspy when there's too much. Yeah, I'm hearing a real crunchiness on that, which I don't think is going to work very well. That's too much crunch. And I still hear it here. Yeah. I hear a lot of crunch out of that. So it's not too horrifying on voices, not as much as I thought it might be, but that is still too much crunch. So we need to take this back. SB rebound needs to be a smaller number when it is. Shall we play a little game with all of this? Because it's possible to play a little game with all of this. We're going to a maximum number of 64, which means we could be playing golden ratio games. And let's see what that gets us. So instead of 32 and 32, it's going to be like 39 or 40 and something else. Let's just use the numbers it gives us. And then, let's see now. Inverse is 382. So that times 64 means this number, rather than being 32, is 24.448. So that's all very fussy, and that's not actually recognizable as a golden ratio reference, but those who are watching the stream get to know that. And we'll see whether that just happens to be a useful degree of grit on some of these things as we go. We could make it scale also. But that might not be needed. Let's check and see if it's obnoxiously gritty. If it is obnoxiously gritty, I might just choose to scale it the same way this is being scaled, or this is being scaled. All this stuff is using parameter 2 slightly differently. It's a very fussy little parameter, this damping parameter, so it's really tricky to get it to behave. And part of the challenge there is there is no right answer for how this works. I'm wrestling a weird audio algorithm that's doing a bunch of strange things. So this is not one of the circumstances where you can go, oh, this is the correct thing to do. I read it in a book. Or I asked ChatGPT. ChatGPT is no help for you here. I feel like this might be a little gritty. If we don't push it too loud, that's okay. If we push it, this is us pushing it too loud, so it needs to act consistently. And I feel that's too much grit on the top of it now. And that's better, but then there's too much sustain. So yeah, I think my thought just then is actually going to be the correct one. This needs to get one of these. We need to have it scaled so that param 2 in the middle of its range is leaning towards being a larger number, because the largest of the number, well, hang on, is that even true, though? Just a minute there. If param 2 is made to be a larger number, I'm thinking about this all backwards. We're already scaling down the amount by param 2. It actually needs to be the opposite, because a larger number kicks in this effect more, which is why we took it back from, hang on, SB rebound is larger when it's having more of an effect. Both of these parameters are adding to it, either a fixed number or a scaled number. And having it be closer to a 16-48 split means that there's more of it at all times, and that became excessive. What that means is if I want the parameters in the middle of the range to be less, then param 2 has to be less in this circumstance in order to move stuff farther away from having a profound and gritty and snarly effect. So rather than doing a complicated thing, I can just simply do a single power factor. Probably only that much of one, although I could do a 3 like that. Everything is being scaled in different ways. This is like using one parameter 5 different ways. This is like being a chef. This is my dish. K-param 2, 5 ways. Technically only 3. Let's see if it worked. That's the only real question, is did it work? We are on the last 15 minutes of stream, although I will be back on Thursday. So if we're not driving really hard into it, then it's going to be cleaner anyway. We can always gain stage into it, but we're pushing it as hard as possible to see how the thing reacts. That sounds promising. Interesting. I'm not sure how well you can hear this. I'm hearing it okay. Yeah. So pull that back to there, at which point it doesn't sound as gritty. And then start bringing in the damping. And there's a certain glow that's coming off of it, and I like that. Cool. I feel like this could work. Equal volumes. We can go from way too much reverb. Bring the damping in, but it's still far too much reverb for many things anyhow. And what I'm finding is the entire range is giving me that sort of bloom on the guitar that I want. All the way down to heavily damped. Let's try this sucker on a lead vocal before I go for the day. and it's behaving itself well enough, I feel I can put it back up to full volume again. Also, I should throw some full band stuff on there and see what it does when exposed to that. So we'll quickly do a bit of that too. This is a bass C track, as you've probably heard many times before. All the reverb. Okay. So fall damping is very successfully cutting off the lows without making them become a horrible... Oh God. Spoke too soon. Wow, what the hell was that? Yikes. Let's try that again and explore it a little better. So we're not putting this out while it's doing that. Oh God. I felt so safe. I bet it's because the output peaked out more than it was supposed to. Let's see how many times it does that. Thankfully, I don't have this cranked. Expand there. I'll have to remember it did that. See if I can reproduce it. I'm pretty satisfied, if not with the explosion, with the way this is able to act like it is a plate that's being driven really hard into damping. Because we can always push it less hard and get less damping. There's the way in which the plate is compressing. Okay, now let's turn it right down to 0 and make that explosion happen again. Input pad. There it goes. So what made that happen? Because that's no bueno. Why would it be doing that? Since I know it can do that, I think it is time to go and find something where this condition will not happen. So SBEL is the thing that is causing this. Also, I wonder whether, let's see. This is a darkening thing that might be more useful on the Cape Plate 240 than the Cape Plate 140. That's not necessarily consistent with what a 140 does. So we'll go with that for the time being. Now the question is, can we clamp these feedback elements before they explode? So here's where the output of this is meant to go. It's a fair question as to how loud any of this is meant to be, but might very well be just a bounds checking thing where I can simply clip those to stop them from doing that. So there's that stuff. Here's feedback times regen. Regen actually ends up being a small number. That's 1 times this, times this, times that. Actually, that's weird, but no matter. What we want to do for now, since feedback is happening on all of these different factors, is put in a clamp, because this is what's causing the problem. If we didn't have this, there would be no problem. But the fact that it's capable of doing short bus, and short bus is capable of adding enough to this by plus 2 times this times itself times SBER, that means each of these parameters can become a number that is excessive, either positive or negative, and I don't know which. Because you see, it could be either. It could be either a positive or a negative swing doing this. All I know is that it's capable of blowing up if the feedback parameters go too high, because it's a regenerative thing that's happening, and it's the regenerative thing I have to stop. Well, if we have to do a conditional, which is what this would be, is a conditional, it could be in here somewhere. So what that might involve is splitting this into, oh, it's getting late in the day. I'm going to need to stop. Going to look something like this. But I have to look up what that is. And it has to be made like that. And we'll just have to get back to that later. So I'm going to be strict with myself, seeing as this has been pulling teeth. And we're going to get back to that later. I may have that last minute bit sorted by Thursday, or I may pick up where I left off on Thursday. For now, I hope you enjoy playing with Airwindows Consolidated. I should be able to add the plugin Discontinuity next week. We've got a new version of Cersley, Cersley 3, which I have high hopes for. That seems to be working great. And I'm excited about what's happening with Kplate 140, and also 240 will be the same kind of deal. Only thing is I have to keep it from exploding, because we wouldn't like it exploding. And so on that note, I will talk to you folks later. And I'll see you on Thursday. We'll see where all of this has led. For now, good night. Bye-bye.